Welcome to the AWS Certified Data Engineer Associate Training course. Let me briefly introduce myself as the instructor. I have experience in developing the enterprise system and the cloud architecture for some major companies. And besides this course, I offer tutorial on cloud services and programming on Udemy and YouTube. I also offer courses to prepare for the other AWS certification exam and tutorial on the other cloud services like Google Cloud and Azure on Udemy. And this video course is designed for those aiming to pass the AWS Certified Data Engineer Associate exam. It includes around 10 hours of video content that explain the key points frequently tested in the exam. And it covers all the services within the exam scope. And the hands-on videos are provided, allowing the practical real-world learning. In addition, I will include the practice question to help you prepare. Now, I wish all students best of the luck in passing the exam and continuing to enhance your skill. And thank you for joining us. Welcome to the AWS Certified Data Engineer Associate Training course. This course is organized into 4 main sections. In Chapter 1, AWS Certification Exam and Preparation. In this section, you will receive an overview of the AWS Certification Exam and explore the various study methods. In Chapter 2, Introduction to each service, we cover all the services featured in the exam, providing through an introduction to each service. In Chapter 3, the practice questions. In this chapter will provide the statistics and important tips related to the certification exam. And the final chapter summary, I'm going to introduce the additional learning resources and the service resources to help your preparations. So, alright, in this section, I'm going to introduce an overview of AWS, the detail of the certification exam, and how to set up an AWS account. Now, first of all, let's talk about what AWS is all about. AWS, or Amazon Web Service, was founded in 2006 and has grown to become the leading cloud platform. It began its journey as a service within the Amazon.com and gradually expanded to offer services like the virtual servers and the storage, known as infrastructure as a service. Today, they now offer over 240 services and continue to grow their market share. AWS offers its services globally. As long as you have an internet connection, you can access their services. Their services are available in 245 countries and territories, with 32 regions and over 100 availability zones. And this is the cloud market share. Over the past few years, the AWS had held about a third of the global cloud market share. Since its foundation, AWS keeps top share. The AWS certification is highly recognized and is one of the most popular in IT world. And this is a comparison between cloud and on-premise solution. One of the main benefits of the cloud services is how easy it is to deploy the resources over the internet. In addition, you only pay for what you use, which usually means lower cost. But moving to the cloud is not just about saving money. The standardizing the infrastructure can also make management easier. Let me give you a quick overview of how AWS started. In the early days, AWS grew alongside Amazon.com's business. The demand in e-commerce changes with the season, like during the Christmas and Black Friday, when lots of products are bought and Amazon system get busy. To make better use of their resources, Amazon decided to rent out their extra server capacity to other companies during the off-peak times. AWS officially launched in 2006. That same year, they introduced the S3, an object storage service, and EC2, a virtual server services. Now AWS offers over 240 different services. And lastly, for your reference, I'd like to introduce the comparison chart for the three major cloud providers. This is given by Google Cloud. All three cloud providers offer similar services. If you've had experience with Google Cloud or Microsoft Azure, this comparison chart helps you understand AWS well. And for those looking to study not only AWS but also for other cloud services, the document can be quite handy. Next, I will introduce learning paths. In this section, I will explain learning methods for different certification levels. The AWS offers certification exam at three levels: the foundational, associate, and professional. The foundational level is designed for beginners just starting to learn AWS. The associate level is for those with about 1 year of practical experience, and the professional level is for those with 2 or more 3 years of experience. And if you're a beginner preparing for the foundational exam, I recommend starting with the video content that provides an overview of AWS services. The official AWS documentation can be overwhelming because it has a lot of information, which might be too difficult for beginners. To grasp the basics, I suggest using the packaged video content from the platform like Udemy to get an overall picture. And if you already have practical experience and already familiar with AWS, I recommend focusing on complementing your existing knowledge. And generally, the video contents contain more information than the document data. It says that the 1 minute video content is equivalent to the over 30 books in terms of information volumes. However, this comparison is about the amount of information, not the knowledge you can get. Watching the 1 minute video doesn't provide the same depth of knowledge as reading 30 books. And video learning is typically a passive learning style, while document-based learning is more active. And for advanced learner in particular, the document-based learning tends to be more efficient. As you progress in your AWS journey, adapt your learning style to match your growing expertise and increasing the complexity of the materials. When it comes to the studying, there is no one-size-fits-all approach to studying. The learning style is different by person, and the time needed to pass the exam is also different by person. And easy and hard are subjective and are not universal truths. In addition, the Roma was not built in a day. The engineering skills are built over time. The IT world is rapidly evolving, so there is no end to learning. Make the most of any free time and find a suitable way to keep learning. Earlier I told you that the way of studying differs from person to person. In this course, I will be breaking down the AWS services by category, and after that, providing the practice questions. Whether you want to dive into the lecture first or tackle the question is totally up to you. And this course also includes some hands-on exercises. I'll guide you through the steps using the management console. Next, I'm going to introduce overview of the exam. And here is an overview of the AWS certification exam. As previously mentioned, the exams are offered at the 3 levels: the foundational, associate, and professional. Currently, there are no prerequisites for taking this exam, which means you can take them at any time based on your experience. For example, you can take a professional level exam without holding an associate certification. In addition, the AWS also offers the specialized certification in advanced networking, machine learning, and security. There were major changes made to the lineup 2024. The database and data analytics exam were discontinued, and a new data engineer associate certification was added. And furthermore, the AI practitioner and the machine learning engineer associate were added. It's expected that the AWS will continue to add or discontinue certification to align with industry trends. And here is the lineup of the associate exam. As of the 2024, there are 5 different certifications available. Starting from the top left, the SysOps Administrator exam is for the operational managers. The Developer exam is for the developer and focusing on the development tools. And the Solution Architect exam are usually tested on the wide range of services use cases, since they work closely with customers. The data engineers focus mainly on the data analytics tools, and the machine learning engineers are tested on the AI and machine learning tools. And this is a list of services category for all associate exam. And you can see that the solution architect has the widest scope of exam. However, the difficulty level will be about the same among these exams. The solution architect are required to have a wide range of knowledge, but other areas require specialized knowledge. And for your reference, this is the top paying ranking of the IT industry. It is notable that there are 3 AWS certifications in the top 10, including the Google Cloud and Microsoft Azure. There are 6 cloud-based certifications in the top 10. Today, the cloud computing is the most important skill for not only infrastructure engineers, but even every IT engineers. If you want to broadly advance your career in the IT industry, it is highly recommended that you study for cloud certification. At all levels, the exam consists of either the multiple choice or multiple response questions, where you will choose the correct answer from option A, B, C, and D. The associate exam has a duration of 130 minutes and consists of 65 questions. The exam fee is $150. Since the exam is lengthy, it's very challenging to keep concentrations. Before taking the exam, I highly recommend that you practice by timing yourself and getting accustomed to the exam session. According to the exam guide, the target candidate should have 2 or 3 years of experience in data engineering and 1 or 2 years of hands-on experience with AWS services. While you don't actually need to have the years of experience, but I highly recommend that you study thoroughly because the exam is challenging. The exam consists of 65 questions, but only 50 of the questions will impact your score. In other words, 15 questions will not affect your score. These 15 questions are used by AWS for research purposes. Therefore, you may encounter questions about the services which do not appear in the exam guide. The passing score is 720 out of 1,000. And this is the content outline for the certification exam. The exam guide provides the weight and the content domain. And in this course, we will focus on the services that will be appeared frequently on the exam. And lastly, and this is the sample questions. And you will need a short sentence and choose the option that best matches. I have prepared the practice test in Chapter 3. Next, I will introduce how to create an AWS account. And first, I will introduce the tools for developed and managing in AWS. The Management Console, or simply the console, is a tool that allows you to manipulate graphically via a web browser. It is the first page you access after creating an account, from which you can access various services. The CLI, or command line interface, is a tool to control services via the command line. You can access the AWS environment using the access key and the secret key. And there is also the Cloud Shell, which allows you to access the console once and control the CLI from your browser. You can manipulate the CLI without any setup. And SDK, the Software Development Kit, is a tool for developing the various AWS services. It provides the language-specific APIs for each service, such as Python and Go. And you can access the AWS with an access key and a secret key. And this is a step to create a root account and IAM user. And first, create a new AWS account and then set up IAM user. The IAM is a service that manages the permission of the users in AWS. I will explain it again in the next chapter. First, search AWS in your browser and go to the AWS web page. And you will see the button in the upper right corner that says Sign into the console, and click it. And if you already have an account, you can sign in from this page. To create a new account, click Create a new AWS account. Enter your email address to authenticate your email, and the verification email will then be sent to that email address. Next, enter your personal information such as your address, the credit card, and the phone number. A credit card or debit card is required for your billing, even if your billing is 0. And if you are not belong to the corporation and use AWS for personal development or just learning, I recommend you to choose the basic plan, which is free of charge plan. For developer plan and business plan, you can get support from AWS customer engineers. And once you have completed this process, the AWS account will be created successfully. And this is a page called the Management Console, and this will be the main page when you use the AWS resources from now on. Now, I'm gonna configure IAM. The first account that created is called the root user, and it will be a powerful account like an administrator with access to your credit card. If the account is compromised, there is a security risk. Therefore, AWS recommends that you create an IAM user and sign in as an IAM user instead of using the root user. And first, type IAM in the search window above and move to the IAM dashboard. And this is the IAM dashboard. In the initial state, the root user has MFA, is marked with the red triangle. It is recommended that you install the token apps on your smart devices. And next time you sign in as a root user, authenticate with MFA. And next, create an IAM user. The next time you sign in as usual, sign in as an IAM user. You should not sign in as a root user except when checking your credit account. Now click on the user in the left menu bar, then Add User. And set the username first, and check the access key and the password field for the credential types. The access key is used for the API, CLI, and SDK, and the password is used to sign in the management console. Select the Attach Existing Policy directory and choose the Administrator access. And this will give you the IAM user the privilege to accept the credit card access. And tags can be any text you like. The tags allow identification of IAM user. If you create multiple users in the future, you may set tags to identify each user. And after successfully creating a user, and be sure to save the access key and the password that displayed. You can also download this in CSV format. And when you have done setup IAM, you will return to the console again, and I will briefly introduce to the structure of the screen. From the menu bar above, you can move to various management screens, and you can return to the top page by clicking the AWS logo on your left. And click on the Services to see all the services offered by AWS by category. And you can also register frequently used services as favorite. And click on the CLI logos to open the Cloud Shell. And by doing so, you can manage the command line from within your browser as well. Click on the bell mark to view various notifications, and you can find out about the event, changes, and the incident for the services you are operating. And click on the question logo to get support. The type of support available depends on the plans. For example, the basic plans allow the ticket-based question about the fees, while technical support is available with paid plans. By clicking on the gear-shaped logo, you can edit the language, the visual mode, and so on. And this is a recently added feature. The menu bar configuration may change in the future. And next, click on the bring down where the region name is listed to navigate to AWS region. The Northern Virginia is selected by default. And basically, by selecting the region that is close to where you want to deploy your services, and you can access your resources with low latency. And also, the services deployed and the fees vary slightly by region. Since the AWS is a US company, so release generally the earliest in the US region, and then after rolled out to other regions. A document and the other information is available in English for the latest services, and is gradually being translated into other languages. And finally, you can check account information you have created from the upper right corner of the console screen. And clicking on the organization will take you to the AWS Organization Service page, where you can view the information about the organization you belong to. And from here, you can also check your service quotas and usage status and so on. And if you need to access credit information, you will need to sign out of your IAM user and sign in as the root user. Let's start Chapter 2, Introduction to each service. In this chapter, I'm going to introduce each AWS services that appear on the exam. I will explain by these domains. And firstly, I will introduce the recent trend in data analysis. With the technological development such as the generative AI, the world of data analysis is becoming increasingly complex. the company's systems are becoming faster, the business data is diversifying, the data formats such as batch, stream, and unstructured data are diversifying, and the data analysis methods themselves are also diversifying. The demand for the data analysis is increasing in these uncertain and fast-changing times. The series of the steps from collecting, the processing, and analyzing the data is called a data pipeline, and this is an image of the typical data pipeline. Firstly, the data is collected from the diverse sources including the company databases and unstructured datasets, and at this stage, the unprocessed data is called as the raw data. The data can be ingested through methods such as streaming, batching, the manual upload, or automated integration via the APIs. Now I will explain data types. Structured data has a specific schema or format. Because of its organized nature, it's easy to search and query. The unstructured data doesn't have a specific form or structure. It's harder to query compared to structured data because it doesn't have structure. And the semi-structured data is somewhere between structured and unstructured data. For example, the JSON, XML, and certain NoSQL databases where data might have the hierarchy or the key-value pairs. Next, let me introduce the differences in timing of data collections. The batch processing is a method of processing data in batches with a certain amount of data or with a certain period of time. The data is processed all at once. And the streaming is the method of processing data in real time as it arrives or it's produced. The data is processed immediately after being generated or received. Next, I will introduce data lakes, data warehouses, and the data marts. The data lake is a storage for raw data in its native format. It includes the structured, the semi-structured, and unstructured data. The data warehouse is a system used for reporting and data analysis. It is a centralized repository of integrated data from one or more disparate sources. And the data mart is a subset of a data warehouse. It is designed to cater to a particular business area. You can think of the data mart as a scaling down, more focused version of the data warehouse. Next, I will introduce data processing. The ETL is a typical data processing technique. The ETL stands for extract, transform, and load. The extract is the process of retrieving data from various sources like the databases, APIs, or flat files. The extracted data is then transformed into a format suitable for the target system. The transform is the process of modifying and cleaning data to meet the business or analytical requirement. And finally, the transformed data is loaded into another target system. The ETL is traditionally used with the batch processing systems where the transformation is done before loading. And recently, with the cloud-based data warehouses like Amazon Redshift, the ELT has become popular. It can transform the data after loading. I'm going to explain how ETL process is with easy example. The table shows a list of the names, the phone number, the email, and the age. The John Doe is duplicated in the name field. In this case, you can choose whether to allow duplicate or eliminate duplicate. And the phone number has to be numeric data type, but some characters are mixed in. And there are some blank in email addresses field. and some of the age fields contain invalid numbers. When an irregular value is found, you will predefine rules and convert it to appropriate format. In actual business, raw data often contain missing or irregular values. By processing these kind of data appropriately, the accuracy of the data analysis can be improved. Then finally, I will introduce data analysis and visualizations. Traditional way of data analysis is using standard SQL to specify conditions and process data. The method for data analysis has become more diverse. Recently, the generative AI has become familiar. The machine learning involves the complex processing using the multivariate and the statistical mathematics, requiring the specialized knowledge. But by utilizing the AWS free managed services, you can easily perform analysis. And the BI, the business intelligence tools, are a solution to visualize the data, giving the business insight. The BI makes informed decisions by providing the business metrics and the KPI. In this course, I will introduce each service along the data pipeline. The collection domain includes the Kinesis and the data migration services, and the storage and the data management includes the S3 and the Lake Formation as data lakes, and the Redshift as the data warehouse, and the relational database as the data mart. The processing includes the Glue, EMR, Lambda, the Step Function, and MWAA. The analysis and the visualization includes the OpenSearch and the QuickSight as well as Athena, a query service. And the SageMaker is an IDE for AI and machine learning. And the data security is also required across these data pipelines. So from next page, I will explain these services. Next, I'm going to introduce collection domain. In this chapter, I'm going to introduce data types and the data format, and the collection-related services including Kinesis, SQS, the managed service for Apache Kafka, the migration services, and other services. Firstly, I'm going to introduce data type and format. There are structured data, unstructured data, and semi-structured data. The structured data has a specific schema, usually stored in the relational databases. For example, it includes the fixed size data and the relational database. The unstructured data is a flexible data type. It doesn't have a specific structure, such as text, the videos, and the photos. The semi-structured data is between structured and unstructured data, which includes the document, the files such as the JSON, the XML, or NoSQL database. Today, many unstructured data is generated, especially with the social media and the multimedia content. It's harder to analyze unstructured data than the structured data. I'm going to introduce data types which appear on the Data Engineer exam. The CSV, or comma-separated value, is the simple format where each data record is separated by the line, and the fields in the record are separated by the commas. It's universally understood by many applications. The JSON or JavaScript object notation is a lightweight, text-based data format. It's human-readable, making it a popular choice for web APIs. JSON can handle hierarchical or nested data structures. The Apache Aurora is a row-based storage format suitable for both the serialization and the deserializations. It's schema-driven, which means the schema definition is stored with the data. It is used for data transport between languages and the platform. And the Packet is a column storage format optimized for the big data analytics. It offers efficient data compressions and encoding schemas. It will integrate with Hadoop ecosystem. And ORC, the optimized row columnar. The ORC is also a columnar storage format. It offers high performance with the compressions. It is primarily used within the Hadoop ecosystem. In terms of data storage efficiency, the ORC and the Packet are the lightest because they are columnar storage and the advanced compressions. The JSON and the CSV tends to be heavier than that. The AppFlow can vary in size, but is usually lighter than JSON and CSV. As there are data compression methods, the Amazon Athena and Redshift support the compression method listed here. Particularly, the Snappy is recommended as it improves the processing speed when combined with columnar storage. Next, I'm going to introduce Amazon Kinesis. The Kinesis is one of the important services among the data analytics, which includes not only collection domain, but processing and analysis. Here, I'm going to introduce all the Kinesis services. In the data collection step, there are two methods, streaming and batch. The streaming sends data quickly, often within seconds and minutes. The batch takes longer, from minutes to days. For streaming, the data is processing and analyzed in real time. In addition, it's required to respond to sudden increase in the workload. The Kinesis is a collection of services that handle streaming data. The Amazon Kinesis data streams, or simple KDS, collect and process the streaming data in real time. Amazon Data Firehose captures streaming data and transform it and load it into target services. The Amazon Managed Service for Apache Flink is a service to analyze the streaming data. It supports SQL and Apache Flink. And the Amazon Kinesis Video Streams, or KVS, is used for streaming videos. The KVS is outside the scope of data engineer certifications. Next, I'm going to introduce Kinesis data streams. The Amazon Kinesis data streams, or simply KDS, is a free managed service for collecting and processing large volumes of real-time data streams. The streaming data consists of data blocks of any size, such as log stream, events, the data feeds, and IoT data. The KDS is a real-time streaming service which processes streams to less than a few seconds. The KDS has high scalability. As the data volume increases, it automatically scales up the streams. The data can be replicated to multi-availability zone to ensure the data durability. And it integrates with EMR, the Lambda, the Redshift, S3. With KDS, you can make streaming data analytics, the dashboarding. In Kinesis, the data sender is referred to as the producer, and the data receiver is referred to as the consumer. In the following pages, I will introduce their respective tools. I will explain ingestion and delivery on the producer side. For data ingestions, the records are divided into data blocks and partitions. And based on the partition keys, the data is divided into partitions. The partition key has a hash value which determines which shards to be added to, based on the hash range that each record has. And I'm going to introduce some metrics related to the Kinesis. Monitoring the metrics per shard is crucial when determining the number of shards. The record put rate, representing the the number of records written per second. The limit per shard is 1,000 records per second. The byte put per shard indicates the amount of data written to be shard. The throughput limit per shard is 1 megabyte per second. If these limits are exceeded, you need to increase the number of shards to process data in parallel. Next, let me introduce Kinesis Producer Library. This is a library designed to efficiently send records to KDS. It supports not only Java, but also C++ and Python. The KPL automatically read-write in case of failure. It supports both synchronous and asynchronous APIs, reducing the load on applications. It improves the visibility by sending internal statuses and the metrics to CloudWatch. By batching multiple records in a single request, the KPL reduces the number of API calls, which helps lower cost. It also compresses records before sending them, saving network bandwidth. Overall, the KPL simplifies the management of shards and data in Kinesis. The Kinesis agent is an agent that collects log files on the server and transfers them to Kinesis data streams or data firehose. It is installed on servers such as EC2 instances to stream log information. And here are the key features of the Kinesis agent. Next, let's introduce the consumer side. A consumer is a data target that retrieves data from Kinesis. By using the Kinesis Client Library or KCL, you can build a multi-threaded application that reads data in parallel from the multiple shards. The KCL is a helper library designed to enable developers to efficiently read data. The records are retained within the shard for 24 hours to a maximum of the 365 days. During this period, the consumers can retrieve the same data multiple times. The KCL is a library designed to simplify the development of the consumer applications that retrieve and process data from the Kinesis data streams. The KCL, when used together with the Kinesis Producer Library (KPL), that simplifies the shard management. For example, it automatically handles the shard assignment when the number of shards increases and decreases. Using the KCL, the multiple consumer can share multiple shards, and this enables the shard discovery and the load balancing across shards. The KCL uses DynamoDB to manage the record sequences and the checkpoint. The KCL uses DynamoDB to manage releases and checkpoint. The workers retrieve data from the Kinesis data streams and references the DynamoDB release table to determine which shard it should process. And the image shows how DynamoDB release the table managed releases. The release key means shard ID. The checkpoint means the sequence number of the last processed data records. And the release counter is used for a version management of releases, and the release owner is the worker ID that owns the release. The KDS offers two capacity modes, the provisioned mode and on-demand mode. In the provisioned mode, you can manually determine the number of the shards, and each shard is allocated with ingress capacity. The cost is based on the number of shards provisioned every hour. On the other hand, with on-demand mode, it automatically manages the capacity. It provides a default ingress capacity. It scales automatically based on the throughput peak in the last 30 days. Next, let's discuss the enhanced fanout. Enhanced fanout is the feature that provides a dedicated throughput for each consumer, reducing the latency. It allows up to 20 consumers to be registered. Each of these 20 consumers is provisioned with 2 MB per second of dedicated throughput, resulting in a total throughput of 40 MB per second. And this is significantly higher than the standard throughput of 2 MB per second. Additionally, enhanced fanout enables the data to be directly pushed to consumers using the HTTP/2, and this reduces the latency to as low as the 70 milliseconds. And I have summarized the quotas of KDS. Each shard can fetch up to the 1 MB and 1,000 records per second. And shards can also be reallocated among the shards. In other words, it supports resharding. The data retention period is 24 hours by default and can be extended up to 365 days with an additional charges for data retentions. In terms of performance, the data latency is less than 1 second. It can also read up to 2 MB of data per second. In the context of real-time processing, the KDS is often compared to SQS, and here is a summary of the differences between KDS and SQS. The SQS used for message queuing service, the KDS used for streaming data processing. And please keep in mind that generally the KDS offer more advanced features such as ordering and throughput. From this page, I will introduce some common issues in Kinesis data streams. The first one is hot shard. A hot shard refers to the shard where data is concentrated, and this is happened because of a lot of requests sent to a specific shard. In Kinesis data stream, each shard has its own throughput capacity, and the data is loaded to shard based on the partition keys. To address this issue, you can design systems to distribute the data more evenly by adding random prefixes or including the element such as the timestamps or regions in the partition keys. Additionally, the throughput issue may arise when the data is concentrated during the specific time period. In such cases, increasing the number of shards during the peak times to enable the parallel processing can be an effective solution. Next is the data duplications. When unauthorized or network errors occur at the producer side, the Kinesis sends the same data multiple times. In such cases, the same data may be sent to multiple times. To avoid data duplication, you need to assign a unique IDs on the producer side and implement the logic on the consumer side to eliminate the duplicate. Next is the data ordering issues. In Kinesis, the ordering is maintained within the same shard, but it is not maintained across the different shards. If you want to maintain the data ordering, you can use a single shard. However, this approach poses the risks of the reduced overall throughput. Alternatively, you can assign the sequence number on the producer side and control the order on the consumer side. However, this may increase the load on the consumer side. And these are the common issues and the countermeasures in Kinesis. And this topic is also covered in the certification exam, so please review it thoroughly. Next, I'm going to introduce Data Firehose. The Data Firehose is a service that groups streaming data sent in real time and transforms it into a format that is easier to subsequent steps to process. The streaming data flows continuously, making it difficult to process in its raw form. Therefore, it is grouped based on the certain size or time interval. For example, the data is grouped and processed every 60 seconds, and this means that the Data Firehose is not free real-time, but rather near real-time, offering the performance close to real-time. Additionally, the Lambda functions are integrated into the back-end of the Data Firehose, allowing for simple data transformations. Data processed by Data Firehose can be delivered to Redshift, S3, OpenSearch, and other destinations. Data Firehose is a free managed service designed to process the large volumes of data in near real time and load it into other AWS services. While Kinesis data streams require shard and throughput management, Data Firehose reduces the need for such tasks. It supports automatic scaling to handle the fluctuation in data volume. A Data Firehose can send data to S3, Redshift, OpenSearch service, and Splunk. Data Firehose allows for data transformation and compressions, and with built-in Lambda function, it can transform data. A Data Firehose groups data either by fixed size or time interval before delivery, enhancing the data processing efficiency. The streaming data flows continuously, but its volume may fluctuate depending on the time of the day. In such cases, the grouping data by size or time interval improves the processing efficiency. Data Firehose allows for buffering, enabling you to configure the timing of the data delivery. A Data Firehose supports compression and encryption, helping to reduce the storage cost. And with built-in Lambda functions, Data Firehose offers flexible data transformation capabilities. In Data Firehose, the data transformation is performed using Lambda. For example, you can install a Kinesis agent on EC2 instance to stream logs to Data Firehose, where Lambda functions transform the data. The transformed data is then sent to services like OpenSearch for analysis. The Data Firehose provides blueprints, which are predefined templates to call functions for the data transformation. The blueprint code is also publicly available on Git. The format on the left is the sample log format of Kinesis agent. You can define Lambda function to transform it into JSON format shown on the right. And this is a comparison table of the data streams and the Data Firehose. Data streams require the customization for both producer and the consumer. Additionally, it requires the manual management such as sharding. On the other hand, Data Firehose is a free managed service, and you don't have to manage the infrastructure. It offers the near real-time processing with the minimum buffering time. It's natively equipped with the serverless data conversion with Lambda. Next, I'm going to introduce Managed Service for Apache Flink. The Managed Service for Apache Flink is a free managed service for processing real-time data. Based on the open source framework, the Apache Flink, it is suited for processing large volume streaming data. For example, it can be used in scenarios where log data sent from Kinesis data streams and trigger an alert when the specific threshold is exceeded. The managed service for Apache Flink is a free managed service for real-time data processing. In 2023, its name was changed from Amazon Kinesis Data Analytics to the current one. It's free managed service that allows you to use Apache Flink in the AWS environment. Since it is free managed, there is no need for detailed configuration or cluster management. It provides high scalability. If the data volume increases, it automatically scales. It can process data with millisecond level latency, enabling the real-time data processing. Apache Flink can be integrated with the services like those listed here. You don't have to manage the infrastructure or clusters. You can process data stream using only business logic written in the SQL without needing to manage the data streams or processing tasks. And you can perform the analytics using the standard SQL. Additionally, it supports processing streaming data with Apache Flink and Apache Beam. You can also use the Studio Notebook for data analysis. Since Studio Notebook is integrated with the Apache Zeppelin, you can interactively develop using languages such as the Python, Scala, and the SQL. Apache Zeppelin is an open-source web-based notebook platform. It enables the data-driven analytics and document sharing. The query result can be instantly viewed within the same interface. It supports a variety of interpreters, including the Apache Spark, Python, JDBC, Markdown, and Shell. It is also integrated with many tools such as Jupyter. And finally, I will explain the billing structure. The billing is based on the Kinesis processing unit, KPUs, and the volume streaming data processed. The KPUs are a unit of CPU, memory, and the intermediate storage. To reduce cost, you can optimize your code, compress your data, and set up monitoring and alert. And here, I will introduce the concept of the processing streaming data. When processing streaming data, the incoming data is divided into specific time ranges, and these time ranges are called windows. By segmenting the windows based on the data volume over time, the processing throughput can be optimized. The point when all the data needed for window has arrived is called a watermark. If data for window arrive after a window closes, it will be discarded. However, for important data, the window timing can be adjusted instead of discarding it. The managed service for Apache Flink is free managed, so you don't have to manage the streaming processing. This means you can analyze the streaming data without worrying about the infrastructure. If you need more control over the infrastructure, you can use other services like Amazon EMR or Kafka Streams. Next, I'm going to introduce Amazon SQS message queuing service. First, let me introduce the monolithic architecture and the microservices architecture. In the monolithic architecture, the systems are tightly coupled and run as a single service. And therefore, if any one of the systems spikes, the entire architecture must be scaled. Because of the high interdependency, there is a risk that a single failure will affect the entire system. In a microservice architecture, systems are built as independent components. Each component executes the independent process as a single service. And therefore, each service can be updated, deployed, and scaled with minimal impact on the entire system. Recently, it is trend in the shift from monolithic architecture to microservices. The Amazon SQS is a free managed message queue service. It is the oldest service released before the AWS was founded. SQS is used for loosely coupled and asynchronous connections between the systems, such as the microservices. If a producer sends a large number of messages to the consumer may not be able to process the messages and it may overload the systems. Therefore, by queuing for messages, the process can be offloaded. It can also be used with the Lambda to set the threshold on the number of the queues and trigger events when the threshold are exceeded. And from this page, I'm going to explain how to manage the queues. And here is a summary between standard queue and the FIFO, the first in, first out. And for ordering, the standard queue offers the best effort ordering. In other words, sometimes messages cannot be delivered in an order. The FIFO, they offer guaranteed ordering. Messages are delivered in the exact order. For delivery, the standard queue supports at least once delivery, but there is the possibility of duplicated messages. The FIFO supports exactly once delivery. It ensures no duplicate. And for throughputs, the standard queue supports unlimited number of the transactions. The FIFO supports up to 3,000 messages per second. The standard queue is widely used for applications where the message order and the duplicates are not important. And the use case of FIFO is where the order is critical and no duplicates are allowed. Next, I'm going to introduce message polling. There are two types of polling, short polling and long polling. The short polling returns the message immediately even if the queue is empty. The long polling waits for a message to become available for some times, up to a maximum of 20 seconds. For response, the short polling returns the message immediately, and the long polling is slower. The short polling may increase network traffic due to the frequently the empty responses. The long polling that decreases network traffic by reducing the number of unnecessary responses. The short polling has the advantage of its simplicity, but its disadvantage is lower network efficiency. The short polling is set by default. If you set the long polling, you need to specify the wait time seconds. The short polling is suitable for scenario where the immediate response is required, even if the result is in the empty responses. The long polling is useful for queues with low message volume or for cost saving in scenario where the immediate response isn't the top priority. The visibility timeout is the duration that the message remains invisible to other consumers after a queue has been polled. This means that once message is retrieved, it is not immediately removed from the queue, but is hidden from the specified period. And during this time, other consumers cannot receive the message. The message is processed only after the receiving consumer has finished processing it. The visibility timeout can be configured from 30 seconds up to 12 hours. The use case of visibility timeout is to provide a buffer for reprocessing message in the event of failure. This allows the consumer process the messages again. It also prevents the duplicate message delivery where there are connection failures, as the message will remain invisible to other consumers for the duration of the visibility timeout. Next, a delay queue has the delay period for messages. And this delay period is the amount of time between when the message is sent to the queue and when it becomes visible to other consumers. The use case for delay queue is where applications on the user side require time to process messages before new ones are received. Additionally, in a situation where the certain messages should be processed in a specific order, ensuring that some messages are not processed before others. And this is an images of differences between the delay queues and the visibility timeout. When the message is sent without the delay queue, it is added to the queue immediately. If the delay queue is set, the message sent during this period will not be returned even if the receive request is made, meaning during this time, the messages are invisible to consumer. With visibility timeout, the message will not be returned only during the periods the visibility timeout is set, even if the receive request is made by the consumer. Conversely, before and after the visibility timeout period, the consumer can receive messages. At first glance, delay queue and visibility timeout may seem to offer similar functionality, so I will explain the differences between them on the next page. The delay queue controls when a message is first received. In contrast, the visibility timeout controls when a message, once received, becomes visible to other consumers. For example, if there are multiple consumers, the visibility timeout is designed to prevent the message from being retrieved again by other consumers while it is still being processed. A dead letter queue is the queue to get messages that fail to be processed to source queue. Example use case of dead letter queue is to move another queue when limit of visibility timeout is exceeded, and isolate the problematic messages to investigate the cause, accumulate the message during failover. And for your reference, I will introduce some of the typical APIs for SQS. Operations on SQS can broadly be classified into actions on the queue themselves and actions on the message within those queues. Additionally, it's possible to perform operations on the attributes of the queues. Next is Amazon MQ. Amazon MQ is also a message queuing service. It's based on the Apache MQ and RabbitMQ and support protocols like JMS and MQTT. For reference, the JMS stands for Java Message Service and MQTT stands for Message Queuing Telemetry Transport, and both are protocols for message queues. And this is a comparison for SQS and MQ. SQS is a service developed by AWS. When developing a system on AWS, usually SQS is the best option. On the other hand, when migrating from existing system to AWS, MQ might be used for compatibility. Next, I'm going to introduce Amazon Managed Streaming for Apache Kafka. The Apache Kafka is a distributed processing platform designed for streaming data. It enables real-time data ingestion, storage, and processing. Since MSK is free managed, you can focus on creating a streaming application without worrying about the operational overhead. It automatically manages the Apache Kafka cluster and the Apache Zookeeper. And you can use the Apache Flink within MSK. The MSK ensures the security with network isolation via VPC, IAM, and encryption of the data both at the rest and in transit. The pricing is based on the broker instances and the storage usage. Apache Kafka is an open-source distributed streaming platform. It is a system designed for collection, processing, storing, and delivering the data in real time, and making it suitable for large-scale data processing. Kafka is widely used as the data streaming and the messaging system. And this is a comparison table of MSK, Kinesis, and SQS. And both MSK and Kinesis can process streaming data in real time, so the use case and the functionality are similar. The MSK makes Apache Kafka available on AWS, so it features Kafka functions and APIs. The Kinesis is an AWS original service and supports high scalability and auto-scaling. SQS is most likely to be used for decoupling of the applications. The throughput of SQS is lower than MSK and KDS. Next, I'm going to introduce migration services. In this chapter, I will explain data migration services for large amount of data and the database migration services. Let me introduce to the Snow Family. The Snow Family is a service that uses physical storage devices to transfer the terabytes of data. It also supports data transfer from on-premises to S3 and the data export from S3. The Snow Family is useful for transferring the large amount of data from network-restricted environments to AWS. On the other hand, if we want to transfer a small amount of data in a good network environment, it's better to transfer it over the network. And you can place an order for Snow devices from the console. It takes about 1 week to 10 days for the data to actually be transferred. It's depending on the regions. The secure transfer is possible because of the highly durable physical device and the data is encrypted. And this is a list of the Snow Family specs for your reference. The spec is current one, so please refer to the official AWS document for the latest information. Assume we transfer 10 terabytes of data with AWS Direct Connect connection is established. This is an example calculation and which takes about 30 hours to transfer data. On the other hand, the transfer with the Snow Family takes more than a week, so in this case, uploading via network might be a better choice. And generally, it's recommended to use Snow Family for transferring the large volume of data from on-premise to AWS. The data transferring via network not only takes time, but there is a risk of the data an incomplete state due to communication errors. It is important to consider not only time, but also data quality and cost. AWS Transfer Family is a service for data transfer to S3 and EFS using protocols such as SFTP, FTPS, and FTP. It's possible to use either public endpoint or VPC endpoint. And for authentication, you can assume IAM role to grant permissions. You can also use AWS Directory Service or Employer Custom Authentication Service via API Gateway. The AWS DataSync is a data transfer service to automate synchronization data between on-premises and AWS storage services. It supports S3, EFS, or Amazon FSx for Windows File Server. The DataSync is designed to automate transferring large amounts of data. It can be used for migration, the data processing, the backup, and archiving. And this is a comparison table for data migration services. The Transfer Family is primarily used for migrating data to S3 and EFS, and you can use the transfer protocol like SFTP, FTPS, and FTP. And DataSync offers a high-performance online data transfer. It optimized for migrating large datasets over the network. It is useful for continuous data replication. And Storage Gateway offers hybrid cloud solutions. It supports File Gateway, the Volume Gateway, and the Tape Gateway. And it mainly used for backup, disaster recovery, and so on. There are several methods for database migration. The simplest method is transfer all the data from the source to the destination at once. And if it's difficult to migrate all the data at once, you can start by migrating a portion of data and followed by the remaining differential data. And another method is to continuously synchronize the database between the source and the destination. And in this case, you can use the Direct Connect to quickly transfer the data over high bandwidth connections. Now I will introduce AWS DMS. The AWS Database Migration Service, or simply DMS, is a service that migrates database from the on-premise to AWS or other cloud service to AWS. It supports Oracle, the MySQL, the PostgreSQL, and so on as source and target. Mostly, the DMS supports the latest DBMS version, but you should check the latest information of supported versions from the document. It supports full migration, incremental migration, and change data capture. You can migrate existing data and replicate ongoing changes with minimal downtime. And once the data migration is initiated, you can also monitor the migration status. Now I will introduce the migration process the simple way without the schema conversion. And first, they create a replication instance via the console. And here, you will configure the instance type, the VPC, the subnet group, and the storage. Adjust the instance type and the storage capacity based on the volume of the migration task. And this image shows the replication instance, the source database, and the target database all within same VPC and subnet. But you may need to set port in the security group's inbound routes to allow connection as necessary. And next, create the endpoint for both the source and the target databases. And it recommends to the test connection from the replication instances to the endpoint beforehand. And if you are using Amazon RDS, the connection information is automatically populated. But for other database services, you need to enter connection details like IAM or user passwords. Once the setup is complete, you can create the actual migration task. And this task allows you to adjust the migration method such as full or incremental migration. After the migration task is complete, they evaluate the migration and perform an additional migration of differential data if there are differences. The AWS Schema Conversion Tool, or SCT, is a tool that converts schema views between different database engines. AWS DMS alone doesn't support the schema conversion, so if there is a differences between the source and the target database, use SCT to convert the schemas. You need to specialize the software between the same database engine and SCT between different database engines. SCT agent is installed on each client OS. The SCT also supports converting not only schemas, but also code objects such as stored procedure and functions. To give you a clear image of SCT, I'm going to provide some example. Here, I will introduce the samples from the Microsoft SQL Server to Amazon Aurora's MySQL compatibility. The image shows the conversion of the table schema. In the conversion, the identity has been changed to the auto increment, and the data type of price has been converted to the decimal. And due to the different data type available in the Microsoft SQL Server and MySQL, the conversion is necessary. And next is an example of the stored procedure. Unlike SQL Server, where the parameter names require placed in the @mark, MySQL doesn't need it. Also, the conversion of parameter for data type is necessary, and the declaration differs too. However, sometimes SCT doesn't fully support specific database engine, and in such scenario, you need to manually convert the schema. Lastly, I'm going to introduce Data Exchange and AppFlow. AWS Data Exchange is a marketplace service. You can subscribe to data from provider, store it in S3, and connect it by APIs. You can import and export data to your data pipeline. Regarding cost, the prices vary between provider and the subscriber. You are charged with subscription and the amount of data. Amazon AppFlow is a free managed integration service that enables you to securely transfer data between SaaS applications like the Salesforce, ServiceNow, and Slack and AWS services. It simplifies the process of creating and managing data flows, supporting both event-driven and scheduled data transfer. The AppFlow is designed for scalability and can handle large volume of data. Additionally, AppFlow provides a built-in error handling and the ability to encrypt data both in transit and at rest, ensuring the data security and compliance. Next, I'm going to introduce storage and data management. And this chapter includes Amazon S3, the Lake Formation, EBS and EFS, and the database services. Firstly, I'm going to explain data type and the storage services. The object storage is used for storing data as object, also known as blobs. Each object typically includes the data itself, metadata, and a unique identifier. The object storage system allows you to retrieve an object via HTTP and HTTPS, which is used for web-based content. The object storage is used for many use cases, including archiving, backing up, and storing large volume data. In AWS, the Amazon S3 is offered. The block storage is an architecture that divides the data into blocks, and each with a unique identifier. These blocks work like individual hard drivers. The block storage is used in the storage area network where data is stored in volume, also called blocks. It offers a high performance and low latency, and suitable for environments like databases, where rapid read and write operations are necessary. In AWS, Amazon EBS is provided. And file storage is a hierarchical storage used for organizing the data files. It is used as the regular file system in the personal computers and the servers. And this is probably the storage type you are most familiar with, as it is the most widely adopted consumer product. It can be shared among the multiple clients using the standard protocols such as NFS or SMB. And in AWS, you can use Amazon EFS. And this image shows the storage services according to the frequency of the data access. The services on the left are more suitable for frequently accessed data, while those on the right for less frequently accessed data. While relational databases sit in the middle, the NoSQL databases offer quicker access, and the in-memory databases are fastest, and the Redshift takes more time to retrieve data. And S3 is widely covered, offering the all ranges as it provides the storage classes for a variety of use cases. Next, I'm going to introduce Amazon S3. The Amazon S3 is the most popular object storage. The S3 stands for Simple Storage Service. It offers high durability, availability, and unlimited capacity. Unlike EFS or EBS, you don't need to specify the capacity in advance. You are charged based on how much storage you use. The S3 offers a redundancy by replicating the object across multiple availability zones, ensuring the strong data integrity. And it also supports various data protection features such as the versioning, the MFA authentication, and the encryptions. The S3 is used in the wide range of use cases. It's commonly used for backing up logs and the snapshot of AWS services. It's also used as the data lake for storing the structured and unstructured data, as well as for hosting static content. In S3, the container that holds object is called a bucket, and in S3 Glacier, the container for storing archive is called a vault. S3 offers a variety of storage classes, and by default, the S3 standard class is selected. The standard class is used for frequently accessed data. The standard IA is used for less frequently accessed data. The intelligent tiering automatically moves data to lower cost storage classes based on the access patterns. And one zone IA stores the data in single AZ and is less expensive due to lower redundancy. All of these storage classes provide the 11.9 durability. On the contrary, the availability varies by storage classes. Be careful not to confuse availability with durability. The data stored in S3 is physically stored in AWS data centers. The high durability means the data itself will not be lost, but availability refers to whether the data can be accessed at all times. And the standard IA and one zone IA have a minimum storage period, and even if you delete the data before this period ends, you will still be charged for the minimum storage durations. And for reference, the RRS, the reduced redundancy storage, is no longer recommended, but may still appear as option in the certification exam. Next is the storage class for S3 Glacier. The archive data that is accessed even less frequently than S3 is stored in S3 Glacier. The instant retrieval is used for the data accessed about the once a quarter. The flexible retrieval is the data accessed about once a year, and deep archive is for data accessed less than once a year. The more the frequently accessed data, the higher the storage cost. Conversely, the lower the access frequency, the lower the storage cost, but the retrieval fee increase and the retrieval time are longer. All S3 Glacier storage classes have the minimum storage duration requirement. And you can set up a lifecycle management based on the data access patterns. For example, you can automatically move the less frequently accessed data to a cheaper storage class or delete it altogether. Currently, the lifecycle management can be applied across all storage classes. From here, I will introduce the security features of S3. The security features by S3 include access control, signed URL, calls, encryptions, locking, and versioning. There are three main ways to control access in S3. The IAM policies are attached to IAM user or roles to manage access control. The bucket policy controls access at the bucket level. The bucket owner can set permission for other accounts, and by specifying the object name in the resource attribute, it's also possible to control access at the object level. The ACLs, the access control list, manage access at both the bucket and object level. For account level control, the IAM policies are commonly used, and for bucket level control, the bucket policies are typically applied. On the other hand, the ACLs are an older method of the access control and lack fine-grained control options, so there is generally no need to use ACL today. The ACL can grant read, write, and list permission to object and bucket. On the other hand, you cannot set fine-grained permissions for other actions. For example, the ACL doesn't support conditional access control, such as allowing access only from a specific IP addresses. And therefore, it is common to use bucket policy and IAM policies for authorization management instead of ACLs. And here is the sample bucket policy. The JSON format is the same as that used for IAM policy. For example, you can enforce encryption by adding a condition in the condition field. And this is an example of enforcing server-side encryption. A signed URL allows you to set an expiration time for access to an object, and the access is only possible via the generated URL. Only those who have the URL can access the object. However, if the URL is leaked, the third party may be unable to access the object, so it doesn't provide the complete security. And therefore, the signed URL is typically used for sharing the files for download. And you can also create a signed URL for uploading a file, not just downloading. And this is a sample of the signed URL, which includes the access key ID, the signature, and the expiration time. Additionally, you can restrict access by HTTP method or source IP addresses. Next, let me introduce the CORS, or cross-origin resource sharing. The CORS refers to the sharing of the resources between different origins. If CORS is not enabled, you will encounter a blocked by CORS policy error. And this is an example of CORS configuration. In a web application, when the index file is on the domain 1, and the CSS file is on the domain 2, you need to enable resource sharing between domain 1 and domain 2. With CORS, you can allow requests from the specified domain. Next, let's talk about the data encryptions. The S3 supports encryption for data at rest. There are two types of encryption, server-side encryption and client-side encryption. With server-side encryptions, the data is encrypted by AWS after being uploaded to S3. In contrast, the client-side encryptions data is encrypted before uploading it to S3. For server-side encryption, there are three types: SSE S3, SSE KMS, and SSE C. The SSE S3 is enabled by default. SSE KMS uses KMS for encryption and decryption, and with KMS you can choose between the AWS managed key and the customer managed keys. The SSE C allows you to use key provided by the client, and in this case, the key is not stored in AWS but client location. Make sure to remember the different type of key, where they are stored and who manages them. And for client side, the encryption CSE, since the data is encrypted on the client side and before being uploaded to S3, AWS is not involved in the encryption or decryption. And next, I will introduce the object locking. You can lock objects in S3 to prevent them from being modified, making them read-only. And you can set the retention period for the object lock. Once the period expires, the lock is automatically lifted. To use object locking, you must enable versioning, which I will explain later. There are two retention modes for object lock. The governance mode, which allows only specific IAM user to overwrite or delete object. The compliance mode, which prevents any changes from all users, including the root account. The compliance mode is ideal for log files used in audit. Additionally, there is a feature called the legal hold, which protects the object for legal reasons. The legal hold operates independently of the object locked retention period. This means that even if the retention period has expired, the object will remain protected as long as the legal hold is enabled. And similarly, if the legal hold is disabled, but the object lock is still active, the object remains protected. The object can only be overwritten or deleted once both the object lock and the legal hold are disabled. The legal hold is useful when the duration of the protection is uncertain, such as during the external audit where the end date is not yet known. And you can also set the bold locks in S3 Glacier in similar way. And let me introduce the versioning. By enabling the versioning, you can retrieve previous versionings of the object. On the other hand, even if you overwrite the object, you can still access its earlier version. Additionally, when you delete an object, it's not permanently removed. Instead, a delete marker is created. And if you remove the delete marker, the previous version of the object will reappear as the latest version. To permanently delete an object, you need to specify its version ID when deleting it. And you can enable versioning on a bucket-by-bucket basis. In object storage, every object has the key and ID. When versioning is enabled, a put object request or upload overrides the object with the same key. However, since each version has a different ID, you can refer to each as a separate object. Next, I will introduce S3's operations. And here I will introduce the batch operations, the multi-part upload, the transfer acceleration, and S3 select. And first I will introduce the basic S3 operations. The getObject operation is used to retrieve an object from S3. You can execute the getObject by specifying the object, the bucket, and the condition to retrieve the desired object. Additionally, you can use the list bucket to retrieve a list of objects in the bucket. You can also specify a prefix or size to filter and retrieve specific objects. Next, I will introduce batch operations. The batch operations allow you to perform the actions on a large number of objects at once. For example, you can copy object, invoke Lambda functions, replace object tags, detect object, replace ACL, or manage object lock retention. In batch operation, you can create the job and specify details such as the type of operations, the target S3 bucket, the manifest file, account, and regions. The manifest file is used to specify the object that the operation will be applied to. Next, I will introduce the multi-path upload. The S3's multi-path upload is a feature that allows you to efficiently upload the large object. It works by dividing the object into multi-paths and uploading them in parallel. And once all parts are uploaded, they are reassembled into the original object. And you can also configure the setting to retry failed upload and delete incomplete multi-path upload. Additionally, in multi-path upload, you can specify the parameters such as the number of the parallel upload and the threshold for splitting the files. Next, let's talk about the S3's transfer accelerations. Transfer acceleration is a feature that speeds up file uploads and transfer between regions. When enabled, S3 uses the globally distributed edge location to optimize the upload process. And if enabled, endpoint will be created. Now, I will explain more detail about the edge location in the CloudFront chapter later. In short, edge location acts as a relay point equipped with the AWS networking infrastructure. Lastly, let me introduce S3 Select. S3 Select is a feature that allows you to extract a subset of the data using the SQL. And it supports data formats such as the CSV, JSON, and Apache Packet. And you can run S3 Select via the CLI, SDK, or Management Console. For example, if you have a large dataset, retrieving the entire object with getObject can take a long time. S3 Select helps reduce download time by allowing you to retrieve only the data you need. The S3 Select is no longer available to new customers in July 2024. Only existing customers can continue to use it. Next, I'm going to introduce AWS Lake Formation. Now I will introduce the features of Lake Formation. The Lake Formation supports data sources such as S3 and relational databases. It is compatible with both structured and unstructured data. Since AWS Glue is integrated into the Lake Formation, the Glue crawlers can be used to retrieve schemas from the data sources and save them in the data catalog. Additionally, it can perform the duplication and the transformation of data as needed. It also integrates with IAM, enabling the fine-grained data access control. The permissions can be set not only at the bucket level, but also at the table and the column level. The Lake Formation generates workflow from the predefined blueprint. The workflow includes the AWS Glue crawler, triggers, and the ETL jobs. The metadata obtained by the Glue crawler is stored in the data catalog. The actual data lake is implemented in the S3. The management of lake formation is performed by the data admin. The data admin has full permission in lake formation. And once the data lake is completed, the query executor can perform the necessary analytical operation on the data lakes. Since the data lake is implemented in S3, the queries can be executed using the Athena or Redshift. And the access scope can also be specified as needed. In Lake Formation support both the row and the column level security. Additionally, you can set the cell level security, and this enables fine-grained access control. Next, I'm going to introduce Amazon EBS and EFS. The EBS and EFS are storage options that can be attached to computing services like EC2 instances. The internal storage for EC2 instances is volatile. In other words, if you stop the instance, the data in the internal store will be lost. If you need persistent data storage, you should use the EFS or EBS. The EFS can be attached to multiple instances across multiple AZ. The EBS can be attached to multiple instances by enabling the multi-attach, but due to certain limitations, it is typically attached to a single instance. Both EFS and EBS can be detached from EC2 instances as external storage. The EFS can be used as the shared file storage, while EBS can be saved as the snapshots. And this table compares the differences between the EBS, the EC2 instance store, and the EFS. Again, the EBS is block storage, the EFS is a file storage, and the EC2 instance store is internal storage in the EC2 instance. The connection type for the EBS and the EFS is over the network, while the EC2 instance store used as the local disk. The EFS and the EBS can be used for persistent storage. And in terms of the redundancy, the EBS provides the redundancy within a single availability zone, while EFS offers the redundancy across the multiple availability zones. EC2 instance store doesn't provide the redundancy. And similarly, the EBS and the EFS are scalable, but the instance store is not. And as a reminder, if you need the attached storage across the multiple instances in multiple AZ, use EFS. And for single AZ, use EBS. Now let me introduce the EC2 instance store. The EC2 instance store is a storage that is attached to an EC2 instance. The lifecycle of the instance store is tied to the instance it is attached to. When the instance is stopped or terminated, the data in the instance store is lost. The instance stores are typically used for temporary data storage, such as caching, or in use cases with high I/O requirements. There are different types of instance store, including the SSD, HDD, and NVMe. The capacity and the specification of the instance store vary depending on the instance type. Next, here is a list of the EBS specs. The EBS is a block storage, and you can choose its specs. You don't have to memorize the numbers listed here, and these numbers may be updated in the future. And for now, just remember the categories such as the choice between SSD and HDD, and the IOPS and the throughput. The SSD generally offer better performance than HDD. Additionally, the provisioned IOPS SSD is used for workloads that require higher performance than general-purpose SSD. Also, the higher the specs, the higher the cost. The number at the end, like the GP2 and GP3, indicates the versions, with the larger number representing the newer version. For example, GP3 is newer than GP2 and has improvements such as the better scalability. The only provisioned IOPS SSD supports multi-attach, and only SSD supports the boot volumes. Next, let's talk about the Amazon EFS. The EFS is the NFS-based file storage service. It can be attached to EC2 instances or on-premise servers. To attach it to an on-premise server, AWS Direct Connect is used. The EFS can be attached to multiple instances across the multiple AZ. And it's free managed, so users don't have to worry about the software update or maintenance. Additionally, its storage capacity automatically scales as needed. The NFS stands for Network File System. It's a file sharing protocol designed for Linux, and Amazon EFS is primarily used with the Linux instances. For Windows instances, FSX for Windows is used instead. The EFS offers two performance modes, the general purpose and max I/O. The general purpose is ideal for use cases like the web delivery, the content management, and the form directory. And the max I/O mode is designed for workloads requiring a higher throughput, such as big data analytics or media processing. In addition to the storage cost, there are also charges for provisioned throughput. The EFS has storage classes, while not as many as in S3. The standard is the storage classes designed for frequently accessed data, offering the high durability and availability. And IA, the infrequent access, is a cost-efficient storage class for the data that accessed less frequently, and making it ideal for long-term storage or data that is rarely accessed. And Archive is a storage tier for infrequently accessed, such as a few times per year. You can also set the lifecycle management policy to automatically transition data between these classes. For example, if a file has not been accessed for 14 days, it will automatically move from EFS standard to EFS IA. And here, I will introduce the encryption process for EBS and EFS. When creating a new EBS volume or EFS file system, you can enable encryption using the KMS. However, you cannot encrypt an existing EBS volume or EFS file system directly. Therefore, to encrypt the existing EBS or EFS, you need to follow these steps. For EBS volume, first create a snapshot of existing the EBS volume, then encrypt the snapshot. After that, create a new EBS volume from the encrypted snapshot and reattach it to your EC2 instance. For EFS file systems, you need to create a new EFS file system with encryption enabled, then copy the data from existing EFS file system to the new one. This process is commonly tested in the certification exam, so it would be helpful to remember it here. Now I'm going to introduce database services. Now first, I'm going to introduce overview of AWS Database Service. Let me introduce the types of databases. The traditional table type databases are called RDB or relational database and are generally known as the Oracle or MySQL. A relatively new type of data format is called a non-relational or NoSQL. The NoSQL includes the services such as the key value, document, and the graph types. And here is a list of databases provided by AWS. The Aurora, RDS, the Redshift as the relational databases, DynamoDB as NoSQL, Elasticsearch and MemoryDB as the in-memory databases, DocumentDB is the document-oriented databases, and so on. Now I will describe the general benefits of database as a service. The AWS databases offer free managed support for patching servers, the operational system, and the database management system, as well as backups and snapshot. In other words, you don't have to manage your infrastructure. You can easily create a high availability architecture. With AWS, you can build a master and a replica server with just a few clicks. If your failure occurs on the master, the standby server is automatically promoted to the master server. AWS also supports synchronous replication and automatic failover. In terms of performance, AWS database services support read replica. You can create and read replicas across regions. In addition, it integrates with the reporting and monitoring tools such as CloudWatch. The AWS supports many security features such as encryption at rest and in transit, and access control by IAM. and the advantage of the pay-as-you-go pricing. Next, I'm gonna introduce Amazon RDS. First, I'm gonna introduce the elements of RDS. The RDS offer multiple instance types like other computing services. And here is an example of RDS instance type notations. The notation is almost the same as for EC2 instances. This table shows instance family of RDS. The instance families are categorized into general purpose and memory optimized types. And you can choose a processor as an option, and you can also choose your instance size. And generally, the larger the size, the higher the unit price is. The storage types include the general purpose SSD, the provisioned IOPS, and the magnetic. The magnetic is HDD, and the others are SSD. The magnetic is used for legacy compatibility and is not recommended for usual case. In RDS, the storage is automatically scaled when free spaces remain below 10% for 5 minutes. The next up is RDS Proxy. The RDS Proxy is a free managed, highly available database proxy that makes it easier to scale application by establishing the database connection pool to efficiently manage the connections to database. The RDS Proxy maintains a pool of database connections that can be shared among many application threads, and this improves the application scalability by allowing a more efficient use of database connections and reducing the time and the memory overheads associated with the opening and the closing connections. The RDS proxy supports IAM and the VPC security group, which also improves the security. Now you can also improve the reader performance by caching the result of your queries. And this is an image of the RDS proxy. You can configure both the maximum number of the connections and the connection timeout settings. If multiple applications attempt to establish the connections, the RDS proxy handles these connections, result in the high performance and achieve high availability. Overall, the RDS proxy is designed to efficiently manage database connections, reducing the overhead of the frequently opening and closing connections, and managing the connection lifecycle. Next, let's talk about the read replicas. A read replica is an instance that is replicated from the primary instance as is for read-only use. The read replicas are replicated asynchronously from the primary instance, and you can create up to 5 read replicas with RDS. The read replicas are primarily used to offload application read processing. If you perform write and read operations simultaneously on the primary instance, the load of primary instance becomes concentrated. Therefore, you should distribute the load by offloading the read processing to read replicas. The read replicas also asynchronously replicate data from the primary instance, so they can be promoted to the primary instance. You can take the advantage of this property and use read replicas for the purposes such as the disaster recovery, the migration, and the copying. Now I will explain tips for the read replicas. You can create read replicas in a different region. You can use read replicas for migration to another region or for cross-region disaster recovery. A connection endpoint exists for each read replica. You can focus connection only on the read replicas. The constraints for the read replica differs by the database engine. For SQL Server, it's currently available only in the Enterprise editions. Also, in the case of a SQL Server, it is not possible to create a read replica in other region or multi-availability zones. And for Oracle, it is only available in the Enterprise Edition. You need to use the Active Data Guard to use the read replicas. Also, the read replicas in mount mode cannot be read. In other words, read replica cannot be used for the purposes of distributing read load, but only for disaster recovery purposes. The RDS supports automatic backups, the manual snapshot, and point-in-time recovery. For automatic backups, it performs backup once a day and retains for up to 35 days. You can also take a manual snapshot up to 100 at any time. The RDS also supports point-in-time recovery. When restoring the snapshot, a new DB instance will be created. You cannot restore a snapshot to an existing DB instance. The connection endpoints are also newly created, so you will need to configure networking settings such as DNS for new endpoint. For point-in-time recovery, the restores are performed using the transaction logs that are stored in S3 every 5 minutes. You can specify a time to perform the point-in-time recovery. The restoring from point-in-time recovery also creates a new instance. In other words, you cannot restore a snapshot to an existing DB instance too. The enhanced monitoring includes a detailed OS level metrics. For example, it includes the CPU usage, the memory usage, and disk I/O, and so on. The OS level metrics cannot be got with CloudWatch's standard metrics. And if you want to get metrics on the database performance, enable Performance Insight for RDS. The Performance Insight provides a visibility into performance at the SQL level. The metrics that can be obtained with Performance Insight include the SQL wait events and the database load. You can visualize insight by filtering the specific period of time, so you can see which query affects performance. It can store metrics for 7 days by default and up to 2 years. Next, I'm going to introduce Amazon Aurora. Amazon Aurora is a free managed relational database engine. It's compatible with MySQL and PostgreSQL, providing the higher performance and availability at much lower cost. Aurora is designed to be optimized for cloud environment and highly durable and fault-tolerant, and automatically replicating data across the multiple availability zones and continuously back up the data to Amazon S3. The Amazon Aurora has a similar feature as Amazon RDS, since they both are relational database, but Aurora provides some unique features. From next page, I'm going to introduce each of them. I will introduce the architecture of Aurora. For Aurora, you can manage your instances and the storage separately. You can scale computing and storage independently. And data volumes are stored in 3 availability zones, 2 in each, for a total of 6. This ensures data redundancy. Aurora follows the Cora model, which means that only 4 out of 6 write operations and 3 out of 6 read operations will succeed. In other words, if 2 out of 6 write operations fail, the 4 successful data volumes complement each other to preserve the data. In Aurora, a read and write instance is called a primary instance, and a read-only instance is called a read replica. You can create up to 15 read replicas. The volume on which Aurora data is stored is called a cluster volume. The cluster volumes are replicated to 3 availability zones for redundancy. The units of the primary instances the replica, and the volumes is called a cluster. Aurora has an endpoint for primary instance, replica, and you can set a custom endpoint. To distribute the read load, for example, when connecting to the BI tool, you had better to use endpoint for replicas. Now I will discuss Aurora availability and the failover. In the event of failure of the primary instance, the replica will be promoted to the primary. In most cases, the recovery is less than the 60 seconds. In other words, in some cases, recovery may exceed 60 seconds. Recovery within 60 seconds is best effort. If connected to the cluster endpoint, the endpoint is automatically switched during the failover, so you don't need to switch endpoint. If there are multiple replicas, you can assign the recovery priority. If no priority is set or the priority is the same, the replica with the larger size will be promoted. If the new instance doesn't have the sufficient computing power and memory, the replica with the sufficient capacity will be chosen because it will not be processed properly. And this concept of recovery priority is often shown up in the exam test. And normally, during the failover, there is a downtime for recovery. Then cluster cache comes in. By enabling the cluster cache, the cache is synchronized to the replicas, reducing the downtime during the failover. Recovery time is often less than 60 seconds for Aurora, compared to 60 to 120 seconds for RDS, and less than 120 seconds for SLO. I will introduce the Aurora Global Database. The global database consists of the databases across multiple regions. You can have one primary region and up to 5 secondary regions. Replication and failover between regions usually take less than 60 seconds. The global database is designed to route the application requests to the region with the lowest latency. And this means that when applications access the database from the various global locations, they automatically connect to the nearest region in terms of network latency. The global database enhances the fault tolerance by distributing the database across the multiple geographic regions. A similar feature to the global database is cross-region replications. With cross-region replication, you create a read-only cluster in other regions. The cross-region replication often has the higher latency compared to the global databases. It is used for offloading, backups, and the geographical proximity. Additionally, Aurora offers the capability of a multi-master cluster, which means you can have the multi-writable master instances. In the multi-master cluster, you can have up to 2 writable instances. The multi-master cluster are only supported with MySQL. The multi-master may experience lower performance compared to the standard single-master cluster, especially when ensuring the right consistency across the geographically distant instances. In addition, you cannot enable backtrack feature for multi-master. And as for backups, the Aurora offers more extensive backup capabilities than RDS, and you can use automatic backups for both RDS and Aurora. The Aurora provides continuous backups, whereas RDS provides daily backups. The point-in-time recovery is a feature that you can recover a database at any time within the 5 minutes. You can also clone your database instance, which copies the instance portions. And with Backtrack, you can rewind the database to any time within 72 hours. The backtrack is a feature to quickly move an Aurora database to a previous point in time without needing to restore data from the backup. With backtrack, you can recover your database for up to 72 hours. With backtrack, you don't have to recreate the database and the recovery time is shorter than with backup. To backtrack a database, you may experience a temporary stop processing the database. The backtrack is supported for MySQL-compatible Aurora, and it's useful for development and testing environment where the changes are frequent and the potential for error is high. It's also useful in production for minimizing the downtime in case of errors. Next, I'm going to introduce Redshift, the data warehouse service. The Amazon Redshift is a free managed data warehouse service that can store and analyze the petabytes of data. Redshift is highly scalable, so you can store and analyze data ranging from the terabytes to petabyte. It is cost-effective, you don't have to pay upfront cost, and it's pay-as-you-go system. The high performance with columnar storage, the data compression, and distributed executions. Redshift provides high security through encryption, the access control within VPC. The AWS automatically performs operational tasks such as the backups, the patchings, and the recovery from the node failure. Redshift is one of the most important analytical tools in the context of data analysis. It is frequently questioned on the certification exam. In the first three, I will introduce the architecture of Redshift, and here I will explain the architecture of the Redshift, the key distribution, and node types. And this is a diagram of the Redshift architecture. The architecture is composed of a collection of nodes called a cluster. And within the cluster, there are two types of nodes, leader node and compute node. The leader node is responsible for managing query coordination and directing query to the compute node. On the other hand, the compute node stores the data and executes the query assigned by leader node. Each compute node has a local storage and operates in parallel with the other nodes. Redshift uses the distributed system to process data in parallel across multiple nodes, and this kind of processing is called MPP. The MPP system breaks query tasks into smaller subtasks and distributes them to the compute node and processes them simultaneously. And this accelerates query performance, especially for large datasets. Redshift supports distribution styles such as the key, even, and all. The Redshift tables are distributed across nodes row by row for parallel processing, and the distribution type can be selected based on the amount of data and the query requirement. There are three types of data distribution: key, even, and all. In key distribution, the rows are distributed to slices based on the distribution key, and this is useful when tables are frequently joined on the distribution key. The Redshift can perform joins locally within nodes without shuffling data between nodes, improving the query performance. In even distribution, the rows are distributed to slices in round-robin fashions. Even is default settings and is effective when tables do not join a specific key. In all distribution, the entire table is copied to all nodes, and this allows joining with the table to be executed within each node. This method is typically used for smaller lookup tables. However, it consumes more storage as the entire table is replicated across all nodes. In key distribution, the data is distributed based on the specific key. The values are hashed, and the same types of the value are stored on the same node. In all distribution, all data is copied to every node. In even distribution, data is evenly distributed in round-robin manner. I will introduce the distribution style using the simple example. For example, we have a customer table and the order table. The customer table contains the customer ID, customer name, and the customer email, and it has a small number of records around the 1,000 rows, and serves as the master table. The order table contains order ID, customer ID, the product name, and order date. It has a large number of records, and the number increases the transaction growth. When these tables are joined using customer ID as the key, rows with the same customer ID are placed in the same slice, enabling faster join processing. And this is the concept of the key distribution style. Next, let's talk about the old distribution style. The customer table is a master table, so it is small in size and it can be distributed using the old style. And this means the customer table is copied to each slice. As a result, when performing the operations such as join, no data movement between tables is required. On the other hand, the order table grows larger as transactions increase. If it's distributed using the old style, the copying the table will take a significant amount of time. Additionally, the total storage size will increase, so on cost. And finally, let's discuss the even distribution. When there is no specific key and the table size is not large, the records can be evenly distributed in a round-robin manner, and this is how distribution style works. Now I will introduce the node types of Redshift. In Redshift, there are three options depending on the use case: DC, DS, and RA. And DC, or dense compute, use SSD-based storage and are optimized for compute-intensive performance. They are suitable for cases where the data size is less than 2 TB and the query performance is priority. A DS, or dense storage node, uses the HDD-based storage and are designed for storage large amounts of data, and they are ideal when there is a need to store massive datasets. The RA3 node leverages the SSDs for high performance, while simultaneously storing data in S3, and they allow the independent scaling of the compute and the storage. The frequently accessed data remain on SSD, while infrequently accessed data is offloaded to S3. The RA3 nodes are suitable for scenarios where data growth is unpredictable, requiring flexible storage solutions. And this image shows the differences between DC-DS and RA3. With DC-DS nodes, the compute and storage are provisioned per instance, which you cannot increase only storage capacity or only compute resources. The RA3 allows storage and compute resources to scale independently. DC-DS follows a shared nothing model. In the shared nothing model, each node operates independently. The dataset is distributed across the node, ensuring the parallel processing. On the other hand, in the shared storage model, the multiple nodes share a common storage. The RA3 follows a hybrid model where the compute layer follows the shared nothing, while the storage layer follows shared storage model. Next, I'm going to explain the Redshift performance. Generally, in database search operation, disk I/O accounts for 60 to 80% of the processing time. To achieve high performance, the data warehouses need to reduce disk I/O. The Redshift uses the columnar storage, storing the table by column rather than by row. And this approach saves the similar types of data in the same column, allowing only the necessary columns to be processed, thereby reducing I/O. And it also supports data compressions. By storing the data on a columnar basis, the data compression becomes easier. As a result, the storage capacity is saved and the query performance is improved. The Redshift supports 13 types of encoding for data compression. And the Redshift uses a technique called zoning. The data is divided into the multiple zones, and the unnecessary zones are skipped based on the minimum and the maximum value of each zone to improve the search efficiency. For example, zones are determined using the criteria such as date or processing patterns. And Redshift uses the concept called the workload management. Each queue has the dedicated memory and sets the number of query slots, and the query are routed to a queue based on the WLM. And it's useful when you want to distinguish between the long-running query and the short-running query. With workload management, you can configure the query concurrency and the memory allocation. In addition, you can assign the specific user to specific slots. Then I'm going to discuss the scaling. In Redshift, the computing capacity can be adjusted by adding or removing a node. During the resizing, the Redshift operates in read-only mode. When the amount of data is large, the resizing can take a significant amount of time. To address this issue, the Redshift offers a feature called Elastic Resize. Elastic Resize is a feature that enables a quick and dynamic resizing. Elastic Resize typically completes within a few minutes. In contrast, the classic resize involving the adding node and copying data, and which can significantly increasing the time. The Elastic Resize doesn't perform the cleanup disk space during the resizing, and therefore it may be necessary to run the vacuum operation to free up the disk space. Additionally, Elastic Resize only increases or decreases the number of nodes. It doesn't change the node type. In other words, Elastic Resize only supports scaling out, whereas Classic Resize is required for scaling up when you want to change node type. Next, let's talk about the concurrently scaling. The concurrency scaling adds cluster to scale performance. Even when clusters are added, the endpoint remains unchanged. The leader node ensures the query coordination consistency. Additionally, a caching layer is established for S3 storage, maintaining the data consistency. And this enables linear performance improvement while preserving the data consistency. Next, I will introduce commonly used Redshift commands. First, I will introduce the Data Definition Language, DDL. The DDL includes the commands such as create a table and alter table. The first one is the create external table. In Redshift, there is a feature called the Redshift Spectrum to run query on the data store in S3. By creating the external table, you can create a table for Redshift Spectrum. The alter table append is an operation designed to efficiently move data from the source table to the target table. And this command is optimized to minimize the disk I/O and transfer data at a high speed. The vacuum refers to the operation of collecting disk space and reallocating it. The fragmentation occurs after the delete or update operation, so you need to vacuum. In Redshift, the delete and update do not physically remove data. Instead, they do logical deletions. Therefore, it recommends to run the vacuum regularly to collect space. Since vacuum is resource intensive, it is recommended to execute it during the low traffic periods. The analyze is a command used to update the table statistics. The statistics are utilized by Redshift Query Planner to improve query performance. It recommends to run analyze to refresh the statistics after making significant changes to the data. The Redshift Query Planner interprets the query and optimizes the execution order based on the factors such as the execution time. Next, I will introduce the Data Manipulation Language, DML. The DML includes the commands such as copy, insert, and which are used to manipulate the table data. Since Redshift processes the large-scale data, it's important to use the appropriate command. The copy command is used to quickly load data into Redshift table from data sources such as the S3 and DynamoDB. The Redshift copy command is designed for high parallelism. It automatically divides and loads data in parallel across all compute nodes in the cluster, achieving the high throughput. It is recommended to specify a columnar format and compress the data to optimize performance. Insert is an operational used to add new records to a table. The insert is typically used for inserting the small amount of record. For the bulk data loading, use copy command instead insert, because copy loads large volume data in parallel. Since the insert is a command for adding data to existing table, it is important to consider table constraints such as indexes and the key constraints. A join is an operation task combining two or more tables based on a specific key. When using join, it is important to use an appropriate distribution style to optimize data distribution. Additionally, it recommends to ensure that the statistics for frequently used join keys are up to date. The prepare is to prepare the query in advance and save it. With the command, you can create a query with parameters, and this is useful when the query is executed frequently. Execute is to run the query that was prepared for. For example, in this example, the department and age are set as the parameter. When executed, engineering is assigned to department and 30 to age. The explain command is used to build the execution plan, which shows how the query will be processed. It provides the information to help optimize query performance. You can get the details such as the steps involved in the query processing, the number of the load processed, and the distribution and the cost. And finally, let's talk about the data control language, DCL, and other commands. The Redshift integrates with the IAM and the Lake Formation, allowing the permissions to be set for specific user or roles. It also enables control over the access to specific table or even specific roles. Additionally, Redshift provides a command for managing cluster and retrieving the system information. I'm going to discuss the security features of Redshift. Like other databases, the Redshift provides features such as the data encryption, network security, logging, and auditing. Redshift supports access control for table, databases, and schema, as well as function-level access control and column-level access control for table views. And you need to be careful when encrypting the Redshift cluster. You can only encrypt the Redshift cluster at the timing of creation. In other words, you cannot encrypt an already existing cluster. To encrypt an unencrypted Redshift cluster, you must create a new encrypted cluster and migrate the data to it. And this process is similar to that for the EBS and the EFS. Next, I will introduce Redshift Spectrum. The Redshift Spectrum is one of the most important features of the Redshift. With Redshift Spectrum, you can execute a query directly on the data stored in S3 without loading. The Redshift Spectrum is capable of handling data at an exabyte scale. You are only charged for the query executed, making it highly cost-effective. There are no upfront cost and commitment. The Redshift Spectrum is integrated with AWS Glue, enabling data schema discovery and cataloging. The Redshift Spectrum separates the hot data from cold data. The frequently accessed data is stored in a Redshift cluster, while the less frequently accessed data is stored in S3, optimizing the cost. Additionally, since S3 supports lifecycle management, less frequently accessed data can be archived. The Redshift can execute a query directly on the data stored in S3, which you don't need to copy data S3 into Redshift. The Redshift can also join datasets stored in Redshift with those in S3. And here are the best practices for the Redshift Spectrum. They use a columnar format to reduce the amount of data scanned. They optimize the file sizes to improve query efficiency. If the file sizes are too small, the number of read operations increases. Conversely, if the files are too large, it may negatively impact the query execution time. And it's recommended to partition the data in S3 to align with the query filter conditions. For example, if buckets are partitioned by date, specifying the date in the query can avoid unnecessary bucket scans. Since the Redshift charge is based on the amount of data scanned, reducing the scan volume can optimize the query execution both in terms of cost and performance. Then finally, let me introduce the services related to the Redshift. For analyzing the real-time streaming data, the managed service for Apache Flink is the best choice. On the other hand, Redshift is primarily used for the batch data analysis, as data loading takes time. The Redshift streaming ingestion can ingest streaming data. Both Redshift and Athena support querying data stored in S3. With Redshift Spectrum, you can analyze data directly on S3. Next, I'm going to introduce DynamoDB, the key value type database. The Amazon DynamoDB is a free managed key value database. The key value database have a simple structure with key and values, which allow for faster processing compared to relational database. In DynamoDB, each item has a key and attribute. The key consists of the partition key and optionally a sort key. A data is distributed based on the partition key, and the items are ordered with the sort key. The DynamoDB is used in a wide range of use cases such as content management, the catalogs, and user profile management. I will explain the features of DynamoDB. And since it is serverless, you don't need to manage the server, apply patches, or configure scaling. DynamoDB has a high scalability. When creating a table or indexes, you can specify the throughput to ensure enough resources for stable operations. Additionally, you can adjust the disk capacity for storing data, and the storage is unlimited. Although it is NoSQL, you can use a SQL-like query language called Particle. And it also automatically stores data across the 3 availability zones, ensuring the high availability. From this page, I will explain DynamoDB's features by following items. Firstly, I will explain pricing plan and the capacity mode. The DynamoDB's capacity mode is very unique, and it will be appeared on the exam test. There are two types of capacity mode, on-demand and provisioned mode. In on-demand mode, the capacity is increased or decreased in response to the request. On the other hand, the provisioned mode is useful when you can estimate the amount of requests in advance. In on-demand mode, you pay based on the actual read or write operation you perform. The more you use, the more you are charged. In provisioned mode, you pay for the fixed cost based on the read and write capacity units, RCU and WCU, and you provision in advance, and regardless of whether you free use them or not. And here is an example of the unit calculation. Assume we are processing the 4 kilobyte item. A read operation with a strong consistency consumes 1 RCU. A read with the eventual consistency consumes 0.5 RCU. And the transaction processing consumes 2 RCUs. The write operation consumes 4 WCUs, and the transaction processing consumes double, the 8. By the way, there is no strong consistency in write operation. With the provisioning capacity mode, the WCU and RCUs can be scaled automatically. You can set the minimum and the maximum usage for capacity unit. The image on the left is what it looks like when auto-scaling is disabled. The red line is the provisioned capacity unit, and the blue area is actually consumed capacity unit. If auto-scale is disabled, the extra capacity units are provisioned when the number of the capacity unit is low. Conversely, if the amount of capacity units increases, the performance is to be affected. The image on the right is what it looks like when auto-scale is enabled. You can see that as the blue area increases, the provisioned capacity unit is increased. Conversely, as consumption decreases, the provisioning amount of the area decreases, and which provides the necessary and sufficient capacity units for optimal cost performance. On the other hand, it may not be able to keep up with the sudden spike in the request. So if a sudden spike is predicted, it is necessary to provision the sufficient capacity unit. Next, I will introduce the cost structure of DynamoDB. Similar to other database services, the DynamoDB charges for the read and write request, the data storage, and the data transfer. I will explain the DynamoDB specific cost on the next page. The backup and restore is charged for the storage per gigabyte, and the point-in-time recovery is charged per gigabyte per month based on the table size. There is also a per gigabyte charges for exporting to S3. The automatic backups are also charged per gigabyte per month. The restores are also charged based on the size of the data to be restored. The global table replication is charged for the per replicate write request. The billing unit differs between on-demand and provisioned mode. The change data capture is the ability to send the DynamoDB change data to Kinesis data streams or Glue Elastic View. The change data capture is charged per million change data capture units, with a maximum of the 1 kilobyte write as one change data capture unit. The DynamoDB accelerator charges by hour per hour. The unit price depends on the instance type. And the DynamoDB streams is charged per 100,000 streams read as the one read request unit for each get record API call. I will explain the DynamoDB accelerator and the DynamoDB streams again on the later page. Next, I'm going to introduce the keys and secondary indexes. In DynamoDB, the data is distributed into the partitions. Actually, a partition is a storage area allocated on SSDs. By distributing data evenly through a partitioning, you can improve the performance. Conversely, if the partition has some bias, it may affect the performance. Since partition capacity management is managed by AWS, you don't have to worry about them. However, you are responsible for selecting the partition key. The sample table consists of the order ID, the product name, the price, and the quantity and the date. And we assume that the users will search for order information using the order ID as the primary key. Therefore, we will set the order ID as the partition key. The data on the DynamoDB table is distributed based on the partition key. A sort key is a key for sorting by attribute within each partition. It can be used as the composite primary key to accompany the partition key. In the same table as before, we set the order ID as the partition key and the product name as the sort key. The table will be distributed by the partition key. And furthermore, within the distributed table, the table is sorted by the sorted key. You can then efficiently search by order ID and the product name as the composite key. In DynamoDB table, the hash value generated from the partition key value determines the partition that will be distributed. It is recommended to design the partition to be random values so that access will be distributed. And if you use regular or sequential value as keys, such as date or item numbers, the accesses may be over-concentrated on the certain partition, which will affect the performance. When specifying the partition keys, you can help balance access by sufficing or setting a random value to partition key. Next, I will introduce the secondary indexes. In a key value database, you can improve the searchability within the table by adding indexes. There are two types of the secondary indexes, local secondary index and a global secondary index. The local secondary index, LSI, is an index that uses the same partition key as the main table, but allows a different sort key, and it must be created when the table is created. The global secondary index, GSI, is an index that can use a different partition key and sort key from the main table. It can be created or deleted at any time after the table is created. Now I will introduce the local secondary index, and we have a table with the order ID as the partition key and the product name as the sort key. You can improve the query performance by setting the order ID as the primary key and the product name as the sort key. In this case, it assumes that the user will frequently search using order IDs and the product name as key. In the local secondary index, you set a different sort key than the original sort key. The partition key remains the same. For example, if you specify the purchase date as the local secondary index, you sort by the purchase date. In this case, it is assumed that the user will have a need to execute a query with the purchase date as the key, not just the product name. Next, I will introduce the global secondary index. Consider the same table as before, with the order ID as the partition key and the product name as the sort key. In the global secondary index, we set a different partition key and sort key than original partition key and sort key. In this example, we have set the product name as the new partition key and the purchase date as a sort key. A global secondary index is the beneficial when users query based on the different attributes. Unlike a local secondary index, you can set a global secondary index even after you have created a table, since a global secondary index sets a new partition key and sort key. And if you use the use case involve many secondary indexes or complex querying needs, the relational database are more efficient and cost-effective than DynamoDB. The DynamoDB excels in case where you have a simple key-value lookups. The AWS best practice also recommends that only data of the same nature be placed in one table. The disadvantages of the secondary index include the performance impact, storage cost, and read cost. As for performance, when you make some changes to the table, you must also update the associate index. Therefore, if there are multiple secondary indexes, write cost tends to be higher. As for storage cost, having secondary indexes consume more storage. Creating a secondary index means storing a As for storage cost, having secondary indexes consumes more storage. Creating a secondary index means storing another copy or subset of the data. And as for read cost, the reading from the secondary index consumes RCUs. The secondary indexes speed up query operations that require full table scans, but incur the read cost. And so far, I have introduced the characteristics and the disadvantages of the secondary indexes. Actually, you need to design your indexes while taking into account overall cost and functionality. And this is because the cost and the functionality are trade-off. For some use cases, a relational database may be more cost-effective than DynamoDB. Next, I want to introduce DynamoDB streams. The DynamoDB streams is a function which captures a time-ordered sequence of the item level changes in DynamoDB table. It stores the changes for 24 hours. It captures a record of changes to items, insert, update, and delete. The DynamoDB includes the record and the shard ID. You can use the streams to replicate the item level data from one table to another across AWS regions. You can also analyze the data changes and feed them into other systems such as Amazon Redshift and AWS Lambda. With AWS Lambda, take some action in response to the streams in your table. With DynamoDB streams enabled, you can use global tables. Next, I will introduce DynamoDB Accelerator. The DynamoDB Accelerator, or simply DAX, is a free managed in-memory cache strategy. It's designed to improve the read-intensive performance, offering the microsecond response times for accelerating your data. And DAX offers in-memory caching, which keeps frequently accessed data in RAM, making it unnecessary to access the original table. The DAX takes a write-through strategy. When you write to the table, DAX writes both to the cache and to DynamoDB. I will explain the behavior of DAX. For requests from the application, if there is a cache in the cache layer, the response is returned from the cache. On the other hand, if there is no cache in the cache layer, the request is forwarded to the DynamoDB table. You can set the time to read for the cache. The default is 5 minutes. Therefore, you may not get the latest data of the original table. If you request with strong consistent read, the response is directly returned from the original table, not the DAGs. When you send a write request, the request writes to both the cache and the DynamoDB table, and this is called a write-through. If both writes succeeded, a success response is returned. Next up is global tables. The DynamoDB's global tables let you make copies of the table in another regions. The global tables are called multi-master, which means all the tables are for both read and write. If you change one table, all the other tables update the same way. I'm going to introduce some tips for DynamoDB global table. You need the DynamoDB streams enabled to use the global tables. The DynamoDB streams to make sure that when you write the data, it keeps the same data in all tables. You need the auto-scaling enabled or set on-demand capacity for writing data to use global tables. All tables in different regions must have the same name, write capacity, encryption, the time to read, and the global secondary index settings. I will introduce some APIs of DynamoDB. First, I will explain the differences between query and scan. The scan is to read every item in the table and return all the data. For example, you have a table and you want to retrieve all the data who live in New York, regardless of their user ID. In this scan operation, the DynamoDB reads through the entire table and filter out the item where the city is New York, potentially scanning many items even if they don't match. It is recommended to choose query instead of the scan in terms of performance because the scanning all the table item can be time-consuming. If you scan, it recommends to filter only necessary data. The maximum response size for both query and scan is 1 MB. If the result exceeds the size, it will be paginated. The query is retrieving specific item based on the conditions, and it returns an array of the items. For example, you want to retrieve all orders from the table order, where the customer ID is AA111, and filter by a specific order date. In this query operation, the DynamoDB directly looks for an item with the customer ID of AA111 and the order date of the larger than 2023 January 15, making it more efficient than the scan because it uses the partition key to locate the specific items. In the query operation, the DynamoDB retrieves only necessary data with the keys and skip unnecessary data. It is recommended to choose query instead of scan in terms of performance because scanning all table items can consume lots of time. And if you want to use the scan, it recommends to filter only necessary data. The maximum response size for both query and scan is 1 MB. If the result exceeds this size, it will be paginated. Next, I will explain the differences between batch and transactions. The DynamoDB, the batch operation is useful for writing and reading a large amount of data. You can use batch write item and the batch get item to execute a parallel processing. The batch processing continues until completion even if it fails. Any items that fail to write or read are recorded as the unprocessed items. The transaction is also used for processing large amount of data with grouping the records. Then on the other hand, the transaction is based on the all or nothing principle, which means that if any part of the transaction fails, the entire transaction will be rolled back and fail. You can make the entire database consistent with the transactions. For example, let's take a hotel reservation system. When the multiple reservation requests are sent for a room, the transaction should fail. Next, I will introduce backup for DynamoDB. The DynamoDB's backup includes on-demand backup and point-in-time recovery. The on-demand backups are full backups performed at any time manually. Regardless of size, it can be restored in seconds, so there is no performance impact. The backup remains until you explicitly delete them. The backup is saved even if the original table is deleted. Point-in-time recovery enables the continuous backup of your table, which provides the granular recovery from the accidental operation. It can be saved up to the 35 days. You can retrieve and restore transaction logs every 5 minutes. Therefore, the point in time that can be restored is from 35 days ago to 5 minutes ago. The point in time recovery is reset once it is disabled. For both on-demand backups and the point-in-time recovery, the new tables are created when you restore. In other words, you cannot restore an existing table. When restoring, you can configure the secondary indexes, the capacity mode, the capacity units, and the encryptions. Conversely, the auto-scaling, IAM policies, the CloudWatch, tags, the streaming setting, and the time to live will need to be reconfigured after restoration if necessary. Lastly, I will explain security features of DynamoDB. For DynamoDB security, like any other database service, it includes IAM access control, encryption, and network isolation. And here I will introduce the things specific to DynamoDB. The DynamoDB allows access control using IAM. You can control access not only for table, but also indexes and the DynamoDB streams with unique ID. This is an example of IAM policy allowing action on the DynamoDB table. Usually, actions on DynamoDB tables are executed through API. You can control access to DynamoDB by IAM. Regarding the networking, you can use the gateway VPC endpoint. The gateway endpoint, you can use the S3 and the DynamoDB. And this is a summary of the differences between interface endpoint and the gateway endpoint. The gateway endpoint uses the routing table, so all you have to do is add an entry to the routing table. Then you can manage the DynamoDB with one endpoint, which simplifies the configuration. Next, I'm going to introduce MemoryDB. The Amazon MemoryDB for Redis is a free-managed, Redis-compatible in-memory database. Since the MemoryDB is free-managed, you don't have to apply patches or perform software upgrades manually. The MemoryDB is an in-memory database, executing database operation directly in memory to deliver high performance. The MemoryDB achieves high durability through its multi-availability zone configuration and supports recovery using the transaction logs. It provides a strong consistency for the primary node and eventual consistency for replica nodes. The MemoryDB can retain backup for up to 35 days and support up to 500 nodes per cluster, offering the maximum of the 5 terabytes of the storage overall. However, the actual capacity depends on the node type. The Redis and the Memcached are third-party in-memory stores. The Elastic Cache supports both Redis and Memcached, and the MemoryDB supports only Redis. This table shows the differences between Redis and Memcached. The Redis supports more data types and supports availability, redundancy, and data persistency, whereas the Memcached has the simple data types and is the multi-threaded, which improves the per-node performance. The overall, Redis has more features, while Memcached is characterized its simple configuration and high performance. The components of the MemoryDB include the cluster and the shard within each cluster, and the node within each shard. The nodes are actually EC2 instances, and you can specify the specs. Within the shard, there is one primary node and between 0 to 5 replica nodes, where replicas are read-only. The scaling can be performed by increasing or decreasing the number of shards. For example, if there is one primary node and 5 replica in a shard, a total of 6 nodes per shard, the cluster can contain up to 498 nodes. And if there is one primary node and no replicas, the cluster can have a maximum of 500 nodes. This architecture is the same as when cluster mode is enabled in the Elastic Cache. And here is a summary of the use cases for MemoryDB and Elastic Cache. The MemoryDB is used as a primary database, while Elastic Cache is typically used for caching other databases. Although there are slight differences in the latency and the data durability, the primary difference is their use cases. Additionally, the MemoryDB supports clustering, which is equivalent to the enabling cluster mode in Elastic Cache. The cost of MemoryDB is based on the data write volume and the hourly billing for nodes. Similar to other database services, the cost of node can be reduced by using the reserved node plans, which offer discount for long-term usage of 1 or 3 years. Additionally, upfront payment can further reduce cost. Next, I'm going to introduce the Amazon Document DB. First, I'm going to introduce the MongoDB. The MongoDB is a document-based database. A document database in a JSON-like format that provides a flexible hierarchical structure. And this is a sample document, and the name and address are listed. And the address includes the street and zip. That is, address is the parent hierarchy, and the street and zip are the children. The MongoDB also has the excellent scalability, supports the rich queries, and is highly available. The Document DB is currently compatible with the MongoDB, the version 3.6, 4.0, and 5.0. But you may not have the access to all features. You can use the MongoDB's API and seamlessly migrate your existing MongoDB application to AWS. The document databases are flexible and scalable and are used in the content management system, real-time analytics, the mobile and the web application, the catalog, and more. The document database are schemaless and flexible compared to RDBs, and it's easy to scale horizontally. Compared to key-value type database, the document DB have a hierarchical structure and multiple attributes. It has one entity as the document, so related data can be stored together. And here we have a sample data and a query for document DB. In the sample, the database called the books contained the information such as book title and authors. Although it contained the strings and the numbers, you don't need to define the data format or digit in advance. Also, a single item can have the multiple attributes. Also, we have the sample query of the find, update, and remove. You can specify the database item to execute a flexible query. Now I will introduce the configuration of DocumentDB. The DocumentDB consists of 0 to 16 database instances. You can configure one primary, the read and write instance, and up to 16 replica instances. And you can have the total of 6 cluster volumes that correspond to your database instances across 3 availability zones. And this is similar to Amazon Aurora. The storage size is up to 128 TB. Because the DocumentDB's instance is deployed in the VPC, you can configure network security such as the security groups. The DocumentDB is a multi-AZ and provides high availability even during the failure. If the primary instance fails, one of the read replica is automatically promoted to the primary. And if we have configured the cluster endpoint, the DocumentDB automatically switches endpoint during the failover. Next, I'm going to explain Elastic Clusters, which is generally available in 2022. It provides scaling elastically, which means it performs a million reads and writes per second, and it has petabytes of the storage capacity. There are some functional limitations when using the Elastic Cluster. For example, you cannot change global cluster, the performance inside, and shard keys. Elastic Cluster use hash-based sharding to partition data in distributed storage. The compute node and the storage can be separated and scaled independently. Rather than moving data between compute nodes, it copies data between distributed storage to improve processing efficiency. Next, I want to introduce Amazon Neptune. Here is a sample database of the Neptune. Here, the 4 nodes named Alice, the Bob, and the Charlie, the relationship between each node is represented by an edge. And these are the query sample of Gremlin and Sparkle, the syntax for graph-oriented database. And this is the structure of Neptune. The Neptune cluster are deployed within the VPC. The cluster consists of the multiple instances. The subnets are configured across at least 2 availability zones for redundancy. The Neptune consists of the primary node and the replica, where the primary node supports read and write operation, and the replicas are read-only. And you can add between 0 and 15 read replicas. The read replica is promoted to the primary instance in the event of failure. And you can set failover priority. The rules are similar to Aurora. The replica with the lower number will be promoted to the primary instance first. If the priority are the same or no priority is specified, the one with the larger size will be promoted to the primary instance. Then any replica will be promoted if it has the same priority and the same size. Neptune's storage automatically scales in 10 GB increment up to the 64 TB. A total of 6 data copies will be created, 2 in each of the 3 availability zones. Neptune uses the column model similar to Aurora, allowing rewrite even if up to 2 out of 6 data copy fails. Also, it's possible to write even if up to 3 out of 6 have errors. Next, I'm going to introduce processing domain. In this chapter, I'm going to introduce Glue, Lambda, EMR, Step Function, and MWAA. First, I'm going to introduce ETL processing. The ETL stands for Extract, Transform, and Load. ETL is traditionally used with the batch processing system where the transformation happens before the loading. And recently, ELT has become increasingly popular due to advances in the powerful cloud-based data warehouse. The AWS offers services for both the batch and the streaming ETL. For batch ETL, the AWS offers Glue, and for streaming ETL, AWS offers a managed service for Apache Flink. The EMR and the Lambda are also used for transforming data. Next, I'm going to introduce processing-related service. The first one is AWS Glue. The AWS Glue is a comprehensive ETL tool, and let me first provide an overview of the Glue's functionality. The Glue consists of the several components. The Glue crawler retrieves schema information from data sources, which can include the relational database as well as the semi-structured data. The data schema information is stored in the data catalog. Additionally, the Glue offers a feature called Glue Schema Registry, which can save the schema for streaming data. When needed, the ETL job can be executed. The data transformation can also be performed based on the predefined rules using the Glue data quality. And furthermore, the entire set of the Glue functionality can be managed through the workloads. For example, you can trigger a Glue crawler when an object is added to the S3 bucket or execute the workflow on a schedule. The workflows can be managed by the Glue Studio. From here, I will introduce the features of Glue step by step. First, I will explain Glue crawler, which extracts data, and the metadata store data catalog. The Glue supports a variety of services as a data source, including the database, streaming data, and the various data stored in S3. And not only AWS, it also supports the public cloud services and on-premise services. The metadata obtained by Glue crawler is stored in the Glue data catalog. The data catalog manages the metadata for S3 and the database services. The metadata includes the details such as the schemas, the data format, and the storage locations. And if you want to manage the schema for streaming data like Kinesis or MSK, you can use the Glue Schema Registry. The schema registry is suitable for maintaining the schema consistency in real time or tracking the changes in the streaming data. The Glue crawler automatically infers schemas from the data sources and creates a table definition in the data catalog. And this is an example of the metadata extracted by the Glue crawler. The table information includes the general details such as the table name and storage locations. The table properties contain the information such as the file format and the compression method. The table schema includes the actual table name, the data types, and the attribute information. The AWS Glue has two types of the data structure, the data frame and the dynamic frame. The data frame is a concept from the Apache Spark and representing the distributed collection of the data organized into named columns. The data frames are immutable and can be transformed into new data frames. The dynamic frame is specific to AWS Glue and is designed to provide flexibility for ETL. It is useful when the schema is not predefined in advance. They can be easily converted to and from data frames when they're needed. Next, I'm going to introduce ETL jobs. The AWS Glue ETL jobs support for the various data transformations. The Glue's ETL jobs are based on the Apache Spark and Python. In addition to basic data transformation, you can also create a custom transformation logic. And there are the built-in functions of the Glue's PySpark, such as drop, split, the filter, the join, and so on. With the functions, you can manage the data frame. This is another table for functions. Each functions are defined by PySpark and Scala. Sometimes these functions appear on the exam test, so please keep in mind. And here's the sample code for data transformation using PySpark. To filter a row where the age is greater than 30 and concatenate the first name and the last name, you'd write code like this. In AWS Glue, the dynamic frame is used for the initial data reading and the final data writing, while PySpark to the data frame is used for the actual data transformation process. Next, the Glue's Data Brew is a visual tool that allows you to clean and normalize data without writing any code. It includes over 250 built-in transformation functions, enabling you to easily explore, combine, and reshape your data. The Data Brew supports various data sources, including the data lakes, the data warehouse, and the databases. The Glue's data quality is a feature that allows you to set data quality rules in advance and continuously monitor data quality while receiving the notification if any inconsistency detected. It integrates with the Glue ETL job, the process transformation as needed. For example, you can predefine a not null rule, and if any null values are found, it can notify and fill in the null values. Finally, AWS Glue for Ray is a feature that enables the use of the Apache Ray on Glue. Apache Ray is an open-source distributed computing system used for the parallel processing in machine learning and data analysis. While Apache Spark is suited for a large-scale data processing, Apache Ray is simple and easier to use and has a lower learning curve. Finally, I'm going to introduce Glue's workflow. The Glue jobs are defined based on the worker types. The worker types define the compute resources for Glue jobs. In Glue, each node is allocated a unit called a DPU, the data processing unit. The one DPU representing the 4 vCPU and 16 GB of memory. Next, the Glue's bookmarks allow you to create a checkpoint within the job. When bookmarks are enabled, the incrementally added data will be processed, and which improves the processing efficiency. And you can start Glue jobs based on a schedule or event. You can use cron to execute the ETL task at a specific interval or times. Additionally, you can specify events to trigger a job based on the state changes or specific conditions. The Glue Studio is a tool for visually managing ETL jobs. The Glue jobs are defined using DAGs or directed acyclic graphs. You can define the ETL task in a specific order. And finally, the table shows the summary of the types of computing suited to different dataset sizes. Then you can use Lambda for transforming the small-scale data. However, the Lambda has the limitation on runtime and memory. For example, the maximum execution time is 15 minutes. For small-scale data processing, where the Spark or Ray is not used, you can use the Python shell. For medium-sized datasets requiring the parallel processing, Ray can be used. For large-scale data, the Spark is appropriate. For example, when loading terabytes or petabytes of data into Redshift, the Spark is recommended. Additionally, for processing real-time data such as with Kinesis or Kafka, you can use Glue for streaming. Next, I'm going to introduce AWS Lambda. Lambda is an event-driven serverless computing service. The event-driven means the service is triggered by a specific event and doesn't run continuously. Since it is serverless, you don't need to manage the infrastructure layer, and you are only charged for the execution time of the functions. The Lambda automatically runs code in response to the event and works with various AWS resources. A cloud service that runs function is called the FAST, or Function as a Service. It supports a variety of programming languages, including the Java, Python, and Go, and it can integrate with AWS services, but you must assign IAM permission for execution. The Lambda supports a wide range of use cases. For example, it can be triggered by HTTP request via API gateway, execute a function with the data is uploaded to S3, or run function on a scheduled basis. To better understand the role of Lambda, I will show examples of the following pages. And here is a sample code that integrates API gateway to trigger a function with an HTTP request and retrieve data from DynamoDB. When Lambda processes an HTTP request, it's typically integrated with API gateway. An HTTP GET request is sent from an application on EC2 to API gateway. The API gateway functions as the HTTP endpoint, receiving the request and passing it to the Lambda functions. The Lambda function then processes the request. When the Lambda function is triggered, it retrieves the ID from the query parameter and uses the IDs to get data from DynamoDB. If successful, it returns the fetched data in JSON format. Since Lambda is commonly used for integration between services, it is important to assign the appropriate IAM execution role. In this case, you must grant the roles that allow you to operate DynamoDB. When many requests are sent concurrently, the Lambda launches the multiple execution environment to process them in parallel. And by default, the maximum number of the concurrent execution per region is 1,000. So, if more requests are sent, a throttling error will occur. If the number of the requests increases, and the Lambda function reaches its concurrency limit, causing it to malfunction, you will need to raise the limit. You can increase it to the tens of thousands if necessary. Next, I will introduce the Lambda layer. The Lambda layers allow you to package libraries and dependencies that can be shared across multiple Lambda functions. By storing the commonly used component in Lambda layer, you can reduce the size of your function deployment packages. Before Lambda layers were available, you had to upload libraries and dependency as a zip file for each Lambda function individually. You can set up the versioning and aliases for your Lambda functions. The versionings allow you to keep both old and new version of your code. When you update your code, a new version is created automatically. An alias helps you to create a separate environment like the production, development, or staging. You can have different aliases for different environments to better manage your function. Lastly, I will introduce the quotas for Lambda. The Lambda is charged based on the number of function execution. To prevent the unlimited charges, the Lambda has a timeout settings. The default timeout is 3 seconds, and the maximum execution times per request is 900 seconds, the 15 minutes. Since the maximum time is only the 15 minutes, the Lambda is not suitable for long-running tasks. It's best for short jobs. The temporary storage for the data is limited to 512 MB. The total size of a function on the layer is 75 GB, but this can be increased by submitting the request. And the default concurrent execution per region are limited to 1000, but this can also be increased with a request. And if your function hits the limit during the high traffic, you need to raise the limit. The memory starts at 128 MB and it can go up to the 10,240 MB. And you can add up to 5 layers per function. Next, I'm going to introduce Amazon EMR and Hadoop ecosystem. The Amazon EMR is a large-scale distributed processing platform that uses the Apache Spark, Apache Hive, and Presto. The EMR handles the petabytes of data. As the name EMR, the Elastic MapReduce suggests, it supports a variety of data sources. The computing and the storage can be scaled independently for cost-optimal operations. And not only local storage, but S3 is provided for data persistence. To understand the EMR, you need to understand the Hadoop ecosystem. On the next page, I will introduce the Hadoop ecosystem. Then I'm going to introduce the features of EMR by the agenda. Firstly, I'm going to talk about the Hadoop ecosystem. Apache Hadoop is a de facto standard for large-scale data distribution platform and is collectively known as the Hadoop ecosystem along with its main related tools. The Hadoop utilizes the MapReduce algorithm to perform parallel processing on data stored in HDFS, a distributed storage system. The Apache Spark is also the framework for processing the large-scale data, and which is faster than that of the Hadoop. By performing the computing system in memory, it improves the performance. Apache Hive provides a SQL-like query language called HiveQL on Hadoop, enabling the execution of complex query on large dataset. The HBase is the distributed column-oriented database on Hadoop that allows for real-time reading and writing on large table. Both Apache Hive and Apache HBase are typically run on Hadoop ecosystem. The Presto is a distributed SQL query engine capable of quickly extracting information from various data sources. You can start analyzing and processing big data immediately without the need to set up or manage the framework yourself. Now I will explain Hadoop configuration. The YARN plays a role by managing the resources including the CPU and memory, which ensures the cluster operates efficiently. The MapReduce framework is designed to execute distributed data processing. The HBase is a column-oriented database and suited for operation on large amounts of small data. The HBase offers flexibility and efficiency for handling various data types. On the other hand, HDFS is a distributed file system and used for persistent storage. The image on the left shows the structure of HBase. The HBase consists of the master node and the client node. The master node is responsible for the control of the entire cluster. The zookeeper monitors the state of the cluster and detects failures. And the client node executes a query to HBase. The slave nodes operate under the instruction of the master node and actually operate data. On the right side is the image of HDFS. The master node acts as the name node, managing the metadata for the cluster as well as the file system namespace. And the client node acts as the interface for executing file operation on HDFS. The slave nodes are responsible for the storing and replicating the data blocks operating under the instruction of the master node. The MapReduce is a programming model designed for processing a large amount of data in parallel. It consists of two main steps, map and reduce. In the map step, the model input and transform data into a smaller set into pairs of key and values. In the reduce step, the model output from the map step aggregates the data for each key and generates new pairs of keys and values. I'm going to introduce with a simple sample data flow. The first count the words at initial state. And in the map step, convert the word into the key and the number 1 as a value. In the shuffling steps, grouping the same word. And finally, in reduce step, aggregates the value of data with the same. And this is a simple sample. In practice, the map reduced to be applied to the terabytes and the petabytes of data. With EMR, you can use the standard SQL to execute the map reduce process. Next, I'm going to introduce architecture. The EMR cluster is composed of the master node, the core node, and the task node. The master node manages and controls the cluster. It runs the components such as the Hadoop job tracker and the Spark's Spark context. Both job tracker and the Spark context are responsible for application resources management and job management. And the core node has the HDFS storage and execute the MapReduce task, and the data is stored on the core node. The task nodes exist solely to execute the MapReduce task. They do not have the HDFS storage, so tasks are executed in a stateless manner, and these nodes can be added as the need to enhance the clustered processing capacity. Additionally, each node group is composed of EC2 instances, and you can include the multiple instances in the group or configure instance type. With an instant fleet, the different instances type can be included within a single instance group. When scaling an EMR cluster, you add or remove core nodes and task nodes. You can also configure auto-scaling by setting the rules based on the specific manner. For example, you can configure it to add task nodes when the available memory is low. Next, I will explain the managed scaling. In traditional scaling, you had to manually set the scaling policies and rules. With managed scaling, the process is more flexible and simplified. You only need to define the minimum and the maximum values for units consistent of core and task nodes, and the upper limit for on-demand nodes and core nodes. It supports scaling for not only instance group, but also instance fleet. And this means you can combine different instance types for the scaling. For example, you can configure the instance fleet using the both on-demand nodes and the spot instances. When you set the upper limit for on-demand nodes, the additional nodes beyond the limit will be added as the spot instances. And this is a summary of the scaling method. In classic scaling, the instances are added or removed based on the user-defined scaling policy. The only instance groups are supported for cluster. And the evaluation of the metrics occurs at 5 minutes interval. In managed scaling, the EMR evaluates the metrics, so you only need to configure the minimal settings. It supports not only instance group, but also instance fleet. The frequency of metrics evaluation is also shorter, at 5 to 10 second interval. However, only YARN-based applications are supported. For example, the applications like Presto are not supported. Finally, let me introduce the EMR serverless. With EMR serverless, the infrastructure layer is fully managed by AWS. You can easily launch the EMR serverless by selecting the EMR release and runtime for Spark, Hive, or Breast. The EMR serverless is useful when you want to automate the infrastructure management or when demand is unpredictable. Then I'm going to introduce storage options for EMR. The EMR provides two storage options, the HDFS, the Hadoop Distributed File System, and the EMRFS, the Amazon EMR File System. The HDFS is the local storage of the cluster. The EMRFS refers to the storage area in Amazon S3. I will introduce each on the next page. The HDFS is the storage area on the clustered local disks. The HDFS depends on the life cycle of the node. In other words, if a node is deleted, the data in HDFS is also lost. The scalability and the redundancy also depend on the number of the nodes. HDFS is used for fast processing of the temporary or intermediate data. On the other hand, the EMRFS stores data in S3, ensuring the data persistence. The scalability is unlimited, similar to S3. The EMRFS is used when you need to persist or share data. You can use EBS with EMR to enhance the capability of HDFS. However, unlike EC2 usage, the EBS volume will be deleted when the cluster is terminated. The AWS Step Functions is a state machine service designed for workflows for distributed applications and microservices. It visualizes each service as a component within the workflow. By combining it with the serverless services, you can build a flexible workflow. It makes the microservices loosely coupled, which enable independent scaling. While SQS is useful for serial workflow in the process of decoupling, the step function can be utilized for parallel workflow as well. And this is a sample state machine. It's possible to build a complex workflow, including the parallel processing through the conditional branching. I will explain the component of a step function. The activity worker is a component that executes a specific task. It is the piece of code that works with a task. And activity state is to delegate the specific task to activate worker. It's a way to represent a unit work to be performed. And these are the type of activity state. The wait state means a waiting period. In this state, the process waits until the specified time, and it is often used when you need to synchronize the timing within the system. The choice is for the conditional branching. It directs the workflow to different branches based on the specified condition. The fail is used to express the name and the reason when there is an error within the state machine, and it effectively stops the state machine and returns an error. The parallel state allows for concurrent execution of multiple branches. Once all branches have completed, the workflow will proceed to the final state. And the map state is designed for the parallel processing on dynamic array. It contains an array called the item path and iterates the process within the array. With activity state, you can create a complex workflow. In step function, not only can you make graphical workflow, but you can also use JSON-based language called ASL, Amazon State Language. And here we have the sample of activity state that was referenced from the technical blog. Within the ASL, you can specify the details such as the name of the state, parameter, retry, the result path, and more with precision. The step function offers two types of workflow, standard workflow and express workflow, and here is a brief summary. There are differences in terms of the duration, the pricing model, logs, and history. And the key difference is execution duration. The standard workflow offers up to 1 year. On the contrary, express workflow offers up to 5 minutes. In addition, standard workflow offers more action available than the express workflows. In the context of application integration, SQS and step function are often compared and asked in the exam test. SQS is messaging queue service used to decouple and scale applications. The step function is a service to coordinate multiple services into workflow. And here is a comparison chart. SQS integrates application in a linear fashion, whereas the step function by forming the complex workflow includes the parallel processing, iterative processing. And this is a sample question from AWS exam. A mobile application company has developed an application that extracts metadata from user uploaded photos and creates a photo catalog. The application is hosted on AWS, and the Lambda function extracts metadata from the photos to create a catalog. The metadata is categorized and sent to Amazon Elasticache. In this scenario, the answer is to use the SQS, not step functions. The image of the scenario goes like this. The multiple users are uploading the photos, which are processed in the parallel, but one by one in the linear fashion, so to use SQS is better choice. Considering the scenario, the process is executed for each number of photos. If the number of the user increasing, the higher the cost is. The step functions are built based on the number of state transitions. On the other hand, SQS is cost optimal even for large number of requests and is useful for simple processing. The differences between SQS and the step function is frequently shown up in the exam. Amazon API Gateway is a service that acts as the interface for web application. It's a free managed service that makes it easy to create, secure, publish, and monitor APIs. The API Gateway supports HTTP APIs, the REST APIs, and WebSocket APIs. API Gateway receives events from the client and creates requests for the API. It's often used with Lambda, which sends requests to API Gateway to be transferred to AWS resources. I will introduce the component of API Gateway. The API gateway is associated with endpoint. Through these endpoints, the client can access API resources. The endpoints are created for each stage. The stages are used to separate environment, like development and production. And you can set quotas for each stage by combining the usage plans with the stage. And there are three types of endpoint. The edge-optimized API endpoints route through the global edge locations, making them useful for users around the world. The regional API endpoints are useful when users are concentrated in a specific region. The private API endpoints are used when accessing the API from the specific VPC. Next, I will explain some metrics of API gateway. The throttling is the maximum number of the request API gateway can handle. If this limit is exceeded, the request will be throttled. The throttling means controlling a request when they exceed the threshold. By default, the throttling is set to the 10,000 requests per region, but you can apply to increase this limit. You can also set quotas for each API key. Additionally, you can track metrics like error rate and latency. With monitoring these metrics, you can adjust your architecture design. Now I will explain how to integrate the front end with the back end. The Lambda is the most commonly used integration. A Lambda function handles the request from the client and sends them to the backend. It also returns the response from the backend to API gateway. The HTTP integration is used when the backend is based on HTTP. The private integration is used to send the request to HTTP resources inside the VPC. The mock integration doesn't connect to an actual backend resource. Instead, it returns a fixed response and is mainly used for testing. In API Gateway, you can customize the mapping definitions. If the request format is different, you can customize the mapping template to convert it into formats that the resource can accept. And this is an architecture where the client sends data through API Gateway and Lambda to write into DynamoDB. You can convert the query parameter into JSON to write into DynamoDB. Similarly, you can convert the response from JSON to XML. And here are the setup steps for API Gateway. First, select the type of API Gateway. You can choose from the HTTP API, WebSocket API, or REST API. Next, specify the API name and the endpoint type. And for the API method, you can use the common method like the one listed here. You can also set the integration type. A typical service to integrate with API Gateway is Lambda, which can handle the request it receives. Before deploying, you can run a test by specifying the query strings for the API. And finally, when you deploy, an endpoint URL is generated. I will introduce the usage plans. A usage plan sets the number of requests and the throttling limit for each API key. It is used to give different access levels to multiple applications. For example, you can allow free plan users to make 1,000 API calls per month, while pet plan users can make 10,000 calls. This helps prevent excessive use of the resources and maintain preset usage level. Now I will talk about improving the performance in API Gateway. And you can improve performance by enabling the caching. And this allows API Gateway to reuse responses from the backend for the same request. And this reduces latency and offload on the backend. and however, you will be charged based on the caching capacity. The API gateway supports encoding, which compress the data size and reduce latency during the data transfer, and it automatically compresses response payload using gzip. Next, I will introduce the security feature of API gateway. That you can install the client certificate in API gateway, and not only that, you can also create and verify this certificate. Additionally, you can set resource-based policies. The authentication method in API gateway includes the IAM, the Cognito Authorizer, and the Lambda Authorizer. You can restrict the execution role of API to specific IAM user. With the Cognito Authorizer, the client includes a token obtained through the sign-in via the Cognito user pool in the authentication header when making the request to API gateway. The Lambda Authenticator allowed for the custom authentication or the use of third-party authentication. The pricing is based on the number of API calls received and the amount of data transferred. There are no charges for data transfer with private APIs. To understand how API gateway works, I will explain serverless architecture using API gateway, Lambda, and DynamoDB. For example, assume we are building a book-selling application. Through this app, you can add and get information on books in the database. First, the client application input data for a new book. The application converts the data format and sends it as a POST request to the API gateway. API gateway receives the request and routes it into the Lambda functions. The Lambda function passes the JSON data from the request and creates a new record in DynamoDB. The first client will create a JSON file. The book information includes an ID, which is considered as the primary key, and the book title, the author, the genre, and the price. And there is an empty table in DynamoDB at the initial state. The client will send a POST request and the API gateway received it, and this includes the endpoint of the API gateway. The JSON object also includes the request body. And once the request is sent, it will route to DynamoDB from the Lambda function, and the data is written into the DynamoDB. Next, assume we will get information about a book from DynamoDB. The client will get information about a specific book through the application. The application sends the book ID to the API gateway as a GET request. Upon receiving this request, API gateway routes it to the appropriate Lambda functions. The Lambda function passes the book ID from the request and fetches the book record from DynamoDB. And finally, the data is returned to the client via the API gateway. The client will send a GET request to the get the information with the book / the get / 123. It means the get data with the ID of 123 from a DynamoDB table named the books. Once DynamoDB receives the request, it sends the response back to the client. I will explain the security feature of the API gateway. It's a common practice to include a security token in the request. This allows the server to associate each request with the appropriate client. And this is an example of HTTP request with API token. The API gateway is highly scalable. When a large number of requests are sent from the client, normally the 429 error is returned, but API gateway automatically scales to handle the request. The API gateway has maximum processing the count called the throttling. By default, it can handle 10,000 request rate per second and a burst of the 50,000 requests. The moreover, you can increase this throttle count. And here I will introduce the exponential backup. The exponential backup is used to handle the throttling of API requests. When throttling error occurs, it's designed to automatically retry sending requests from the application to the server. The SDK natively includes the exponential backup as its retry logic, so you don't need to manage the retry logic yourself. Exponential backup works by waiting a certain amount of time after detecting the error before sending the request. If an error is detected again, it increases the wait time before resending, and this helps to reduce the unnecessary request as much as possible. I will also introduce the definition of API. The API, or Application Programming Interface, refers to the exposing the part of the application to the Internet, which is shared with third-party applications. By using API, you can eliminate the developing the application from scratch, which leads to cost reductions. In addition, API can enhance security and enable retrieval of the latest data from external applications. Additionally, I will introduce REST. The REST is a set of design principles suitable for coordinating the multiple software components in distributed system. It has the characteristics listed here. The API gateway supports not only HTTP API, but also REST API. Next, I'm going to introduce Amazon MWAA, the managed workflow for Apache Airflow. The Apache Airflow is an open source tool for orchestrating the data pipeline. With MWAA, you can run Apache Airflow as the managed service on AWS. MWAA includes the scheduler and the DAGs to execute the workflow. The DAGs are stored in S3. The execution environment for Apache Airflow runs on the EC2 instances, and the monitoring and logging for workflows are handled through a CloudWatch. A directed acyclic graph, DAGs, refers to a graph that has direction and doesn't contain cycle. In contrast to DAGs, there are undirected graph and a directed cyclic graph. An undirected graph doesn't have the directionality. For example, instead of only having the direction from node 1 to node 2, the reverse direction from node 2 to node 1 can also exist. For example, it includes the network diagram and the social media relation graph. A directed cyclic graph has both directionality and cycles. Because of the cycles, the same node may be repeatedly executed, such as the sequence 1, 4, 3, 2, 1. In contrast, a directed acyclic graph DAG has directionality and no cycles, making it ideal for workflows that require order and task dependencies. And this is a summary regarding the use of the data pipelines. In particular, the focus on differences in use cases. The MWAA supports large-scale data processing, including the frameworks like Spark and Hive with complex pipeline and dependency. The Step Functions is a serverless state service that orchestrates the AWS services. The Glue's workflow is used to build the ETL pipeline. If you want to use services other than Glue, you will need to use another workflow service separately. The SQS is mainly used for decoupling services and handling asynchronous processing. Next, I'm going to introduce analysis and visualizations. In this chapter, I'm going to introduce Athena, OpenSearch, and SageMaker. As for EMR, Redshift, and Kinesis, I have already introduced in the previous chapter. I'm going to introduce the visualization tool QuickSight. And these are analytical tools of the AWS. For interactive analytics, you can use Redshift, Athena, and OpenSearch service, which you can get the query result immediately. For analyzing the streaming data, you can use the managed service for Apache Flink. Moreover, the EMR supports Apache Spark streaming, enabling the real-time processing. For big data analytics, you can use the Redshift and EMR. Redshift is employed for SQL analysis on petabyte-scale data. The EMR provides the framework with distributed parallel processing. And for machine learning, you can use SageMaker. Firstly, I will explain Amazon Athena. The Amazon Athena is a tool for querying and analyzing data stored in S3. It allows you to execute a query on the various data formats in S3. Since Athena is a serverless, you don't need to manage the infrastructure, which you can start querying data immediately. You only pay for the queries you execute, and there are no server running costs. The Athena is built on the Presto, the distributed SQL engine. It supports data formats like a packet and ORC, improving the query performance while reducing cost. Athena uses the standard SQL to analyze data format by Apache Hive, including the packet, CSV, JSON, ORC, and Apache AppFlow. Athena integrates natively with AWS Glue. The Glue automatically detects and catalogs metadata, simplifying the table management. The Athena adapts the schema on read model, where the schema is applied at the query time, and this allows the raw data to be stored. In contrast, the schema on write models require both data and schema to be stored, and enforcing the schema compliance during the data ingestion. The Athena directly queries data stored in S3, which you don't need to load the data into Athena. You need to create a database and a table in order to query data with Athena. There are two ways to create a table: defining the DDL manually from the Athena console, or using the Glue data catalog. When defining the DDL in Athena, you need to manually specify the table schema, data location, and the data format. The Glue data catalog is natively integrated with Athena. It automatically discovers schemas, the catalog data, and supports versioning. Generally, using the Glue alongside Athena, it simplifies the process. I will introduce the workgroups. The workgroup is a feature that segments the environment. You can configure access permission for users or teams, isolate the environment. The workgroups are used for environment isolation, the restrictions, and access control. For example, if you want to grant access to the production environment only to specific IAM user, the workgroups can be used. Each workgroup is assigned an ARN, which allows you to define the permission for each ARN using the IAM policy. With federated query, you can execute a SQL query across the multiple data sources. In addition to data in S3, you can analyze the relational and non-relational and customer data sources. And you can define your own custom function as UDFs, the user-defined functions, and call them within the SQL queries. Using the Athena's Query Federation SDK, you can implement these functions in Java, and they can be invoked from the Athena as Lambda functions. By utilizing the UDFs, you can standardize the frequently used operation and enhance the query functionality. The cost of Athena is based on the amount of the data scanned. For example, in the Tokyo region, it costs $5 per terabyte. Since the cost is based on the data size stored in S3, you can reduce cost by compressing the data. I will introduce the best practices for optimizing the query performance. First, ensure proper file sizes. And if you run query against a large number of small files, the query performance will be low down. For columnar formats, it recommends to keep the file sizes between 128 and 512 MB. You can improve query performance by merging or splitting the file as needed. And it's recommended to use columnar formats, and this allows only the necessary column to be read, reducing the I/O operations. And set up the appropriate partitioning to make the query efficient by filtering the data. And this avoids reading unnecessary data. And compress the files to reduce both read times and storage cost. I will introduce the partitioning and bucketing. The partitioning divides the data into the directory unit. By partitioning data based on the query, you can improve the query efficiency. For example, when selecting the logs by date, the partitioning by date improves the query performance. The bucketing divides the file based on the specified columns. The file size affects query efficiency if it's too large or too small. An optimal file size is typically between 128 and 512 MB. The partitioning and bucketing are independent concepts, so both can be used simultaneously. And so far, I have introduced the best practices for improving the Athena's performance. The AWS's technical blogs feature a top 10 ways to improve the Athena performance, and I will share it here for your reference. Next, I'm going to introduce OpenSearch service. The OpenSearch service is a search and visualization service. You can collect large-scale, real-time data, and you can use queries to interactively search logs from dashboards. The OpenSearch is a distributed search and analytics service. It's developed by the OpenSearch project and licensed under Apache 2. Originally, the Elasticsearch and the Kibana were developed by Elastic, but in 2021, they were moved to public license. And subsequently, the AWS led the creation of the new OpenSearch project. I will explain the architecture of OpenSearch. A document is the smallest unit of data. It's similar as a record in relational database. A document is usually formatted in the JSON and contains the information about the specific entity. An index is a collection of the document. It corresponds to a table in the relational database, where each document can be correspond to a row in that table. An index is where the data is stored. An index is also made up of the one or more shards. A shard is a self-contained index. Each shard contains a subset of the data of an index and functions independently. And each document has a unique document ID. During the sharding, a hash value calculated from the document ID. Next, I'm going to explain node type. The data node actually holds the data and handles operations such as create, read, update, and delete and search data. Each data node contains several shards, both primary and replica. The primary shards hold the original data, and the replica shards contain the copies of the primary shards data for redundancy and load balancing. The master node, or the administrator node, is responsible for the management tasks such as creating or deleting the indices, the keeping track of which nodes are part of the cluster, and deciding which shard to allocate to which node. The master node doesn't hold the data. When determining how many number of the node, you need to take the data volume, redundancy, and the query load and the read load into consideration. The next is the storage tier for OpenSearch. The outer warm is the storage tier for between the hot data and the warm data. It provides up to 90% cost savings than hot storage within the node. For less frequently accessed data, you can store them in EBS or S3. And you should take into balance between cost and performance into consideration to determine which storage to store the data. And by the way, if you store in S3, you cannot change the document but delete by index. From here, I will introduce the performance of OpenSearch. I will focus on the topics unique to OpenSearch. So let's start with the sharding. In OpenSearch, the documented shard is between the 10 GB and the 50 GB. Additionally, the recommended number of the shards is 20 to 50 per node. If the number of shards is too high, the shards become overly distributed, which increases the query latency. On the other hand, if the number of the shards is too low, the resources become concentrated, leading to resource exhaustion and decreased performance. If the shard size is too large, it may exceed the node memory, which degrades the performance. On the other hand, if the shard size is too small, the number of shards increases, impacting the efficiency. And it is important to configure an appropriate shard size and shard count for optimal performance. The bulk indexing is the operation of indexing the large number of documents at once. The OpenSearch offers the bulk API, which allows the bulk indexing, the updating, and deleting. With bulk indexing, you can reduce network overhead. By sending the large number of documents in one request, the number of requests is reduced. The deep pagination is the process of accessing the pages that are far back in the large dataset when paging through data. The OpenSearch offers limitation of the pagination using the from and the size parameter. The sum of the from plus size must not exceed the index max result window, which defaults to 10,000. The OpenSearch offers a search after to retrieve the documents that come after a specified values. To give you an image of search after, I will show you a sample query. A run query to get 10 documents in ascending order by timestamp and descending order by ID. Suppose we can get the result in the list of documents, and we got the timestamp of the 10th document and the ID. The query retrieves the next 10 documents after the 10th document retrieved by the previous query. Like this, you can efficiently retrieve a large amount of data beyond the from and size limit. The OpenSearch offers advanced search capability. Not only simply matching the keyword, you can utilize the more complex query. The OpenSearch offers the ranking and evaluation, the phrase search, the proximity search, the fuzzy search, and the language-based search. And these full-text search features enhance the searching capability, which allow you to find the information efficiently. The OpenSearch provides metrics for cluster, nodes, and shards. The cluster metrics provides the insight into the overall health and status of the cluster. The node metrics are used to monitor the performance of individual nodes, and the shard metrics provide the details such as the number of the shards per node, which can serve as the indicator for load balancing. The OpenSearch provides the index slow logs and search slow logs. It can output logs for document additions, deletions, and updates that take a long time to process. The users can specify a time threshold, and the logs will be generated when the specified duration is exceeded. The OpenSearch supports both API-based analysis and browser-based analysis. The OpenSearch dashboard allows you to search, visualize, and generate reports for data stored in OpenSearch. It enables the interactive The OpenSearch supports both API-based analysis and browser-based analysis. The OpenSearch dashboard allows you to search, visualize, and generate reports for data stored in OpenSearch. It enables the interactive operation and is used for log analysis and system monitoring. The endpoint for OpenSearch dashboard is the same as the domain of the APIs. Only the path is different. The OpenSearch service provides two types of the backups. The automatic backups take the snapshot every hour. The snapshots are retained for up to 14 days. These snapshots are stored in S3, but you cannot directly access the S3 bucket. The manual snapshot allows you to create snapshots to S3 manually at any time. Next, I want to introduce Amazon SageMaker, the integrated development environment for AI and machine learning. The Amazon SageMaker is a free managed service to build, train, and deploy machine learning model. In the building phase, the SageMaker provides a Jupyter notebook. It offers a collection of high-performance algorithms optimized for AI, so you don't have to make them from the scratch. And it supports popular machine learning and deep learning frameworks like TensorFlow, the PyTorch, MXNet. In the training phase, the SageMaker automates the tuning of the parameter to optimize your model. And it can handle the large datasets and perform the distributed training using the multiple instances. And this is a typical workflow of the machine learning. And first, you need to define the problem and collect the data. Next, split the data into the training and the test set. Then select the suitable model, training it, and evaluate its performance on the test set. You may need to tune hyperparameter for optimization. Once satisfied with the performance, you can deploy it. After that, they continuously monitor the model, ensuring its accuracy and maintain over time. And this is for your references. There are categories of the machine learning method. The machine learning can be categorized into supervised and unsupervised learning. Furthermore, their classification, regression, and clustering. The field of AI they heavily utilize the mathematical techniques, including the statistics and the probability, while the data engineer exam doesn't test on these topics, but for machine learning exam will include the question on these models. And this is a list of SageMaker features and the function covered by each. You don't have to memorize all these features listed here, but from the practical standpoint, it would be good to know. And here I will introduce the random cut forest. The random cut forest is an algorithm used for detecting the anomaly. By detecting and excluding anomaly, the accuracy of analysis can be improved. For example, the taxi leadership tends to be higher on holiday during the severe weather or when the events occurred compared to normal day. Next, I will introduce Amazon QuickSight. The Amazon QuickSight is a free managed BI tool. Since it is free managed, you don't need to manage the infrastructure. The QuickSight can scale to accommodate the hundreds of the thousands of users without requiring the infrastructure management as users increase. The QuickSight offers a rich set of charting and reporting features. It supports not only AWS data sources but also third-party tools. With its in-memory database Spice, the QuickSight enables high performance without loading data. To use QuickSight, you need to create an account. There are two pricing plans, the Standard and Enterprise. The Enterprise editions offer more features and provide not only author accounts, but also reader accounts. Additionally, Enterprise Plus Queue includes access to QuickSight Queue. The QuickSight calculated fields are custom fields used to manipulate the data. You can make a simple calculation, aggregation, and more. On the other hand, if you implement large-scale data or complex logic in the calculated fields, the performance may degrade. In such cases, it is better to pre-process the data using AWS Glue beforehand, and then load the transformed data into QuickSight. The QuickSight's ML Insight provides features such as the anomaly detections, forecasting, and the natural language processing using machine learning. For example, by loading past sales data, you can use the machine learning to analyze the trends and predict future sales. The ML Insight is available in the Enterprise Edition. The QuickSight Queue provides the features powered by natural language processing. With QuickSight Queue, you can ask the questions in the natural language and receive the appropriate visualization tools. For example, if you input the show me the top selling item from last week, the QuickSight will interrupt the query and return a bar chart of the relevant data. The next is Spice. The Spice is an in-memory engine developed by Amazon specifically for QuickSight. By using Spice, the calculation can be much faster than directly querying the source data. The Spice automatically scales up and down based on the on-demand. The Spice is built to perform the parallel calculation across the multiple cores, enabling the efficient processing of a large dataset. The QuickSight provides 3 roles. The admin has the full administrative permissions, including the account management, the data source configuration, and the user and the permission management. The author is responsible for creating analysis, the building the dashboard, and the sharing the reports to utilize and visualize data. And the leader builds the created dashboard and analyzes the data using the filtering and the drill down the capability. The quick site provides a row-level and column-level security. Instead of showing the all data, you can control access to specific rows and columns for particular users or tags. For example, the users with the department ID A can view only the data where the department ID is A. To use RLS, you need to create the rules, the map users or groups, and share the dashboard. The RLS rule includes the range of data that can be accessed. Enabling the RLS can impact dashboard performance. When filtering the large amount of data, it may take longer to reflect the changes. The RLS only restricts the data display within the quick site. It doesn't restrict the access to the actual data source. Therefore, if someone has access to the data source, they can view all the data. To ensure strict control over the data access, you must use IAM or resource-based policy to restrict access to the data source itself. From this base, I'm going to introduce some example of graph and chart provided by QuickSight. First, if you want to visualize the time series data, it is suitable to use line chart, bar graph, the combo chart, and the waterfall chart. The time series data includes the data or time. For comparison, you can choose horizontal bar chart, pie chart, the horizontal stacked bar chart, the horizontal stacked 100% bar chart. It visualizes of the relative sizes of the data. Again, for comparison, you can use heat map, tree map, the scatter and bubble chart, and visualize data plotted on maps. And if you want a correlation, the scatter map is appropriate. And this visualizes whether there is any correlation between the dataset. And lastly, if you want to visualize the distribution data, the histogram and the box and the whisker diagram are suitable. As explained, the QuickSight supports many types of the graph and the chart. You can use these tools to visualize data according to the various use cases. Lastly, I'm going to introduce security domain. In this chapter, I will explain IAM, data encryption, the data governance, and monitoring and logging and networking. AWS offers various security services. With IAM, you can control ID-based access. In terms of the network security, the VPC allows for network isolation, and by setting up the firewall, you can manage the access based on the IP addresses, the protocol, and the locations. The encryption for data at rest is important in the context of the data analysis, and AWS has the services for data protection of sensitive data, such as the Amazon Meshi and the Amazon Detective. I'm going to introduce AWS IAM. The IAM, or Identity and Access Management, is a service that manages the access permission for resources and accounts. With IAM, you can control the fine-grained access which enhances the security across your environment. When you create an account, the root user is created, but typically you sign in as an IAM user. An IAM user has a specific permission to perform the certain actions on the specific resources. IAM also allows you to set a permission on resources as well as the users, and this allows for security designs such as the law of the least privilege. Let me introduce the elements of the IAM. The IAM consists of the components such as IAM policy, users, groups, and roles. I will explain each of these elements on the following pages. First, let's talk about IAM user. An IAM user is an identity defined in IAM. There are two authentication methods for IAM users, ID and password, or access key and secret key. The ID and password are used to log into the console, while key pairs are used to authenticate applications and APIs. To enhance security, you can enable MFA, the multi-factor authentication. While IDs and passwords are stored information, and key pairs are more vulnerable to exposure, so it's recommended to set up the additional layers of authentication. When storing the key pairs, follows the principle of the least privilege. Avoid hard-coding the key pairs and instead use the environment variables. And you should also restrict the IP addresses for the users who have the access to key pairs, and rotate the key pair regularly, and periodically check key pairs usage. An IAM group is a collection of IAM users. You can assign the permission to IAM group, which then applies to all users in that group. And this approach simplifies the access management and minimizes the risk for both the over-privileging and under-privileging. As your organization grows and the number of IAM users increases, managing the individual user can become time-consuming. It's recommended to organize IAM group according to the appropriate roles or teams. The root user is the account holder who signs in using the email addresses and password set up when the AWS account was created. The root user have very powerful privileges. Unless restricted by the Service Control Policy (SCP) in AWS organization, the root user can perform any action on the AWS account. Therefore, it is generally recommended to delegate the privilege to an IAM user and sign in as the IAM user instead. Only the root user can perform specific tasks such as configuring the AWS account, managing the billing settings, and suspending the account. The privileges of the root user have been updated several times in the past. For example, as of now, the root user can delegate the support plan changes to an IAM user. Please refer to the official document for the latest update. An IAM policy is a set of the rules that defines what actions are permitted on which resources. There are several ways to classify IAM policy. The one classification is based on the attachment target. The identity-based policies, which are attached to entities like users and groups, and the resource-based policy, which are attached directly to resources. Another classification is by customization method, inline policy, and managed policy. Inline policies are directly embedded into the IAM entity and are used when you want to assign specific permission to a particular entity. When the entity is deleted, the inline policy is also deleted. And there are two types of managed policy. AWS Managed Policy, which are predefined by AWS, and the Customer Managed Policy, which are customized and created by users. In general, AWS Managed Policy are easier to manage and recommended over inline policy. The IAM policy are written in the JSON format. The structure of IAM policy is outlined here. The current policy is the 2012, the October 17th. For reference, the previous version was released on the October 17th of the 2008, and the current version allows more functionality compared to the older one. The statement can contain the multiple conditions. Since an IAM policy may define several permissions, there are often multiple blocks of curly bracket under the statement. And SID is any identifier you choose. For example, in this policy, the EC2 full access is used to identify the policy as one that allows for all action on EC2 instance. And for effect, you can specify allow or deny. And in action, you define the specific operations. Each resource has its own set of actions that can be described in detail. And in this example, an asterisk is used, the meaning any action is allowed. Conversely, if the effect is denied with an asterisk, it means all actions are denied. And the resource field indicates the resource being acted upon. You can also add a specific condition under the condition field. The term ARN stands for Amazon Resource Name, which uniquely identifies an AWS resource. The string equals is used to match a specific string. So in this case, it ensures only a particular IAM user can perform the actions. And this JSON format is often appeared in the exam. Additionally, policies for S3 bucket and KMS keys can be written in JSON in the similar manner. And you can set a detailed condition within the condition field. And this table shows some common conditions. The string equals check if the strings are exact match. For example, it can verify the resource name or tag's name matches. And the similar condition includes the string like and not equal. And the numeric equal check if the numbers are an exact match. The similar condition includes the numeric not equal and the numeric greater than. The bool represents the Boolean value and define a binary condition of either the true or false. For example, a condition might be only valid when the encrypted communication is enabled. And ARN equal check if the ARN matches, and the date equal check if the date matches. IAM policy can be attached to resources as well as identities, and this is called a resource-based policy. I'd like to introduce a couple of patterns that are commonly used. When integrating the services, it is necessary to set the policy properly. And if you forget to set the policy, you will encounter authorization errors, and the service will not be available. And this is especially common with the S3 bucket policy with the CloudFront origin, the execution policy of the Lambda and the SQS. And since Lambda and SQS are services that always work with other services, it's necessary to grant policy. In practice, the authorization errors often happen because the policies are not properly configured, so it's important to keep them in mind. And here is a list of the policy associated with IAM. In addition to identity-based and resource-based policy, there are also permission boundaries, SCP, the service control policy set in AWS organizations, and the session policy set in AWS TS. And you can define these policies in JSON format as well as IAM policy. Now, I will introduce cross-account settings. And this image shows an example of the execution and action from the application running on the EC2 instance to S3 bucket. On the left side is the cross-account setup, and on the right side is the single account setup. In the cross-account scenario, the identity executing the action and the resources receiving the action are in the separate account. In such cases, the only actions that are allowed by both the identity policy and the resource policy are valid. And this means the policy must satisfy under conditions. In this example, only the get object action is valid. In contrast, for a single account, any actions allowed by either the identity policy or the resource policy are valid, which follow OR conditions. In a cross-account setup, if you want to allow a specific action, you must explicitly allow in both the identity and the resource policies. Conversely, for a single account, if you want to deny a specific action, you must explicitly state deny. And this is a simple example with just two accounts and one identity and one resource. However, in real large-scale system with multiple accounts and resources, managing the policy becomes more complex. Next, I will introduce the permission boundary. A permission boundary is a policy that is added on top of an existing policy to apply further limit. In this image, the yellow area that represents the policy and the blue area represents the permission boundary. And as a result, only the permission within the overlapping the green area are allowed. The permission boundaries are useful when you want to limit the actions on the particular IAM user. In this example, by adding the permission boundary that allows or denies a specific action to the IAM identity with admin right, only those actions specified in the boundary will be allowed. The permission boundaries are applied to IAM identity to ensure they only have the minimum necessary permissions, which is important for governance and security. The permission boundaries are applied to individual IAM user and roles to limit the permissions. The permission boundaries in IAM and SCP in AWS organizations are quite similar. The SCPs are used in the organizational hierarchy to limit some of the permission inherited from the parent level. For example, the parent level may allow launching the all EC2 instance, but the child level might not be able to launch the certain EC2 instance. The JSON format works the same way. Next, I will introduce the switching role. A switch role allows an IAM user to switch from one IAM role to another. A single IAM identity can take on multiple roles to perform the various tasks. You can also set up the cross-account switch role, where IAM user in one account can assume an IAM role in another account. To grant a role from another account, the user requests authorization, the other account grants necessary permissions, and once granted, the user can access the resources of the other account based on the assigned permissions. Next, I'm going to introduce AWS STS. STS, the Security Token Service, is a service that provides a temporary access to AWS resources. While IAM grants the permanent credential, STS issues temporary credential with expiration times ranging from a few minutes to several hours. Once the credential expires, the access is no longer available. For security reasons, these credentials are dynamically generated and not stored with the user. The temporary credential like an access key the secret access keys and the session tokens can be obtained through the assume role action in AWS SDS. For example, when providing the access to external user, the manually creating IAM users and assign the policy to each one that makes the operational overhead. Moreover, the granting the long-term permission to temporary user poses a security risk. The session and access data can be stored in the services like DynamoDB, and when a request for credential is made from the role, the STS issue and grants and the temporary credential. I will explain the temporary authentication using the STS between the different accounts. And in this example, the account A is trying to access a resource in account B. And this is a command to get a temporary credential. And here assumes a role named my role. And this will return a response here. The credential field contains a temporary access key ID, secret access key, and the session token. With the credential, the account A can access the resources. You can also set the expiration time for credentials, and once expired, the credential will no longer be available. IAM roles are created to be assumed by a user, service, or AWS account. And in this example, if a user in account A wants to access a resource in account B, the role is created in the account B. The trust policy for that role specified account A, allowing the user in account A to assume the role. Although the role exists in the account B, it is assumed by the user in account A. When accessing the resources in account B from the account A includes the temporary credential obtained earlier in the CLI environment variables. Next, I'm going to introduce Apache Ranger. Apache Ranger is an open source framework designed to manage the comprehensive data security across the Hadoop ecosystem. It provides a security policy consistently across the Hadoop component. The Apache Ranger provides the fine-grained access control for the Hive metastore, and this enables row and column level access control, data filtering, and masking. It allows access control at the S3 prefix and the object level. Additionally, it offers the centralizing the auditing functionality using the CloudWatch logs. And there are lots of the common things between the Apache Ranger and the IAM policy. The table shows the detail of differences. Apache Ranger is mainly used for fine-grained access control within the Hadoop ecosystem, while IAM is used for broad access control on AWS resources. Next, I'm going to introduce AWS KMS. First, I'm going to introduce the encryption in the cloud. In cloud environment, where sensitive data are stored online, encryption is an important measure for protecting the data from malware and ransomware. Encryption is the process of converting digital data into a string of the character that are unreadable by unauthorized user. Since the cloud is online, it's necessary to encrypt both the data at rest and the data in transit. Encryption is the process of transforming the plain text into the unreadable cipher. It uses the cryptographic keys and algorithm. The converted data can be reverted to its original form using the decryption key and the process known as the reversible encryptions. In contrast, irreversible encryption is known as the hashing. It generates a hash value that can be reversed. The hashing is commonly used in the digital signature. And there are the symmetric encryption and the asymmetric encryption method. The symmetric encryption is the method where the same key encrypts the decrypted data. And this method is fast and efficient for encrypting the large amount of data. However, there is a security risk to share the key between the sender and the recipient. Asymmetric encryption, or also known as the public key encryption, involves the two keys, a public key for encryption and a private key for decryptions. The public key is shared between sender and the recipient, and however, only the owner of the private key can decrypt the data. The hybrid encryption combines the strengths of the both symmetric and the asymmetric encryptions. The recipient shares the public key in advance. The sender encrypts the data using the secret key. In addition to the encrypted data, the symmetric key is encrypted using the recipient's public key. The sender sends the both encrypted data and the unencrypted data. The recipient decrypts the common key first, and the recipient then uses the decrypted symmetric key to decrypt the encrypted data. The history of the cryptography is very long. With the advancement in the computing science, it is important to use the latest and the most secure encryption method. The AWS offers the secure method compliant with the standards like FIPS. So let me introduce the AWS KMS. The KMS, the Key Management Service, is a service that helps you to create and manage the cryptographic keys. It supports the creation and management of the HMAC keys, the symmetric key, and the asymmetric key. You can control access to these keys using the key policy and ion policy. With KMS, you can manage the entire key lifecycle from creation to deletion, all in one place. The KMS also offers the automatic key rotation, which reduces the security risk of using the same key for the extended period. The KMS has a key rotation feature. It's recommended to rotate the key regularly, as using the same key for a long time increases the risk of the exposure. By default, the key material is rotated once a year. And even after rotation, the old key material is retained, so any data encrypted with the old key can still be decrypted. The properties like ID, ARN, and the policy remain unchanged. And if you need to rotate the key more frequently, you can manually generate new key material to encrypt the data. Now I'm going to explain the keys and the key materials. A key is a logical entity for data encryption and digital signature. It's associated with the metadata, such as the unique key ID, ARN, the creation date, and the description. The key material, on the other hand, refers to the binary representation of the encryption key itself. The key material is actually used for encryption and decryptions. When importing the external key material into KMS, the user is responsible for generating and backing up the key material. KMS doesn't support backups or the rotation of the external keys. So let me explain the life cycle of the key. A key's life cycle refers to the series of the events from the creation to deletion. The customer master keys, CMK, can be activated, deactivated, and deleted. Once a key is deleted completely, it cannot be recovered forever. The key should not be immediately deleted. Instead, they are first logically deleted and then physically deleted after a waiting period of 7 to 30 days. And during this period, you can reactivate the key if needed. The logical deletion means the key appears to be deleted, but the data still exists. During the waiting period, before physical deletion, any use of the key can be tracked through the CloudWatch and CloudTrail, allowing you to detect compromises. And it is best practice to deactivate the key before deleting, rather than deleting them immediately. The KMS supports the BYOK, the Bring Your Own Key, which allows you to import external keys into KMS. However, the BYOK has some limitations. It doesn't support automatic key rotation, so you need to manually regenerate the keys when necessary. Additionally, you must back up your keys as automatic recovery is not available in case of failure. The BYOK also doesn't support logical deletions. The keys are deleted immediately upon expiration. And this is a procedure for importing the BYOK key. First, download the public key from KMS. Then encrypt your key material using the public key and upload the encrypted data key material to AWS. The KMS allows you to control access to your CMK by setting the key policy. A key policy is a resource-based policy that defines the permissions for who can access and manage the key. The key policies are written in JSON format as shown here, and in this example, the action field has the asterisk as the KMS, which allows all possible operation on KMS. By specifying the action in your key policy, you can limit the scope of the privileges. On the left is an example of the actions for key administrator. The key administrator can manage tasks like key creation, activation, deactivation, deletion, and scheduling. And on the right is an example of the key user actions. The key users can perform the tasks such as the encryption, decryption, and generating the data keys using the KMS. The KMS supports encryption for many AWS services, and the encryption methods differ depending on the service. I will explain the few common examples. The AWS System Manager's parameter store is used to centrally manage the system parameter and access key, and it stores the various strings, both sensitive and non-sensitive. And by default, AWS managed KMS key can be used for encryptions. The AWS Secrets Manager is a service for sensitive information such as the passwords. The secrets are encrypted with the KMS key. The encryption is also supported for database services with different services using the different encryption method. It supports encryption by cluster, table, and data. The EBS and S3 also support encryption. In particular, S3 offers the both server-side and client-side encryption options. And finally, I will explain the pricing. There are two types of the CMK, the customer-managed CMK and the AWS-managed CMK. For customer-managed CMK, there are charges for key storage and the number of requests. And for AWS-managed CMK, there is no storage cost. For reference, let me explain the difference between the Cloud HSM and KMS. The Cloud HSM is a hardware security module using the physical hardware with an anti-tampering features. It's primarily used for the compliance purposes. The KMS is a free managed key management service that integrates with many services. It offers a fine-grained control over the key management, and you can also upload pre-encrypted data to AWS using the customer-managed key. Next, I will introduce the AWS Secret Manager. The Secret Manager is a centralized service that manages the lifecycle of the secret, such as the database credential and password. It supports the periodic secret rotation, which is handled by our Lambda functions. It recommends not to be embed the password directly in the application, but to store them in the Secret Manager. Updating the password within the application may require code changes, which can affect operation. I will explain the differences between the Secret Manager and the System Manager's parameter store. The parameter store is to store the wide range of strings, including the system parameter and the secret, and it's free to use, and it also integrates with many services. On the other hand, the Secret Manager has an automatic rotation feature and is designed for securely managing the secret. And this topic often appears in the exam, so make sure to learn the different use cases. Next, I'm going to introduce data governance tools. The Amazon Macy detects the sensitive information in data stored in the S3 bucket. It uses the machine learning to identify the pattern in the sensitive information. And you can easily enable Amazon Macy through your console, and once activated, it continuously monitors your data. The data detected by the Macy can be encrypted with the KMS, and you can trigger a CloudWatch event as the detections. Macy is capable of detecting the personal health information and the personally identifiable information (PII). It also helps you comply with the regulations such as GDPR, PCI DSS, and the HIPAA. Now I will explain how to comply with PCI DSS. Amazon Macy can detect sensitive credit card data, but it cannot encrypt or mask data by itself. In other words, Amazon Macy itself is not PCI DSS compliant. To achieve PCI DSS compliance, you need to encrypt your S3 bucket to mask the credit card information. The AWS Glues offer the PII detection features. While the Amazon Macy detects PII within the S3 bucket, AWS Glue not only detects the PII, but also provides the capabilities to process it. By using AWS Glue, you can automate the entire workflow from the PII detection to processing. The Amazon Guard Duty is a service that analyzes the storage and logging services to detect a potential threat. It supports logs such as the CloudTrail, S3, the VPC Flow Logs, and the DNS query logs. Like Amazon Macy, you can enable it directly from the console. Detected threats can be linked to CloudWatch event and integrated with the event bridge to trigger necessary actions. The Amazon Guard Duty's threat detection includes identifying the compromised credential from S3, unusual data access pattern, suspicious login, and malicious API calls. When used together with Amazon Detective, it can analyze security events with context, metadata, and resource information to help identify the root cause. The Guard Duty can also scan EBS for suspicious malware behavior. It integrates with the Security Hub and Event Bridge to send threat information to operational tools for further action. And finally, let me introduce to the Amazon Detective. The Amazon Detective is a service that automatically collects the logs data from the various AWS services and uses the machine learning and the statistical analysis to investigate the potential security issues. It integrates with the GuardDuty, Security Hub, the CloudTrail logs, and the VPC Flow Logs. The use case includes when a user accesses your system from an unusual IP addresses through the GuardDuty. When multiple abnormal EC2 instances are launched, and an increase in the failed API calls. The pricing for Amazon Detective is based on the amount of logs data it captures from the CloudTrail, the VPC Flow Log, the GuardDuty, and other sources. Next, I'm going to introduce monitoring and logging. The first one is Amazon CloudWatch. And first, I will give you an overview of the system monitoring. The system monitoring is a process of monitoring a system to ensure that it is working properly. The system monitoring includes the infrastructure monitoring, such as the servers, networks, and operating systems, and service monitoring, such as software, DNS, and load balancer. It also provides a trail of who did what and when, and you can take appropriate action when the problem occurs. And furthermore, it's also necessary to take a history of changes on the resource side, such as whether the resources in operation are compliant with the appropriate rules. The AWS provides the following services: CloudWatch as the system monitoring, and the Config as the resource change management, and the CloudTrail as the trace management tools. So let's get started with Amazon CloudWatch. The CloudWatch is an integrated operational monitoring service. It has many features and can monitor any AWS service, making it the most widely used monitoring tool. The CloudWatch monitors AWS resources and can trigger action and alerts based on the changes in logs and metrics. You can find a complete overview of the CloudWatch functionality here. It collects logs and metrics from the monitored EC2 instances and lays an alert if the preset threshold is exceeded. It also sends a notification via SNS, and it can work with the Lambda function to perform necessary actions. The SNS is a simple notification service, which sends a notification via email or SMS. The CloudWatch logs capture application and server logs and provide a function for analyzing the logs it collects. The logs are records of the activities and the information, such as computer usage and the data communications. In CloudWatch logs, the log retention period can be specified from 1 day to unlimited, which is useful for logging the purposes like auditing. Logs can also be filtered with the standard query. For example, you can filter by specific strings to analyze how often certain errors occur. And this is a sample query that streams VPC Flow Logs to CloudWatch logs and extracts them for a specific time period and address. In practice, the log records can number in the thousands or even tens of thousands, so be sure to filter appropriately to extract only the information you need. The VPC Flow Logs are traffic logs for AWS Virtual Network Service, VPC. The next are CloudWatch metrics. The metrics are the measurement taken over a specific time period, providing the information about the system health and performance. The metrics can be automatically obtained from the various AWS services or through APIs. In addition to standard metrics like CPU usage and HTTP request, you can also create a custom metrics tailored to your need. And beside AWS resources, you can retrieve metrics for on-premises system and other cloud services. The metrics can be collected by handling the CloudWatch agent on Linux and Windows Server. An agent is software installed on the device such as a server or network equipment. The agent collects the data from the system and sends it to the CloudWatch. Next is CloudWatch alarms. The CloudWatch alarms are triggered when the predefined thresholds are exceeded or abnormalities are detected. The alarms can also trigger SNS notification and actions, allowing you to respond to incident quickly. And you can set the statistics to be monitored and the time period, the threshold for triggering the alarms, and the specific metrics to be alarmed on. The alarm states includes the OK, alarm, and the insufficient data. For example, you can set an alarm to trigger if CPU utilization is 80% or higher and more times within the hour. The CloudWatch event allows you to take a specific action based on the events and rule, and you can trigger action on the target based on these events and rules. There are two types of event sources, the schedules and the event. The schedule defines an event, such as the triggering the action on the certain days of the week. The event trigger actions when metrics for resources exceed a certain threshold or when there is a changes in the resource status. And you can define the schedule using the metrics like a rate or cron. Example of the rate and the cron expression are listed here in this table. The target is the AWS resource where the action will be executed. The CloudWatch events are often used in the conjunction with the Lambda functions. And you can set up to one event to trigger another AWS resources to perform the actions. And here I will introduce the Amazon Event Bridge. In 2019, the CloudWatch event was separated into its own service called the Amazon Event Bridge. Functionally, the Event Bridge is fully compatible with the CloudWatch event and even extend its capability. Event Bridge retains the service name and the API that the CloudWatch event used. Additionally, Event Bridge can integrate with the non-AWS resources, which was not possible with the earlier version of CloudWatch event. Next, I'm going to introduce AWS CloudTrail. The AWS CloudTrail is a service that records user activity and API operation as a trail. It logs details like when, who, and what. The CloudTrail captures two types of events, the management event and the data event. The management event involves the creation, the modification, and the deletion of resources, while the data events relate to the operation on specific AWS services. For example, the creating an S3 bucket is logged as the management event, while saving an object to S3 bucket is logged as a data event. The trail includes information such as the event timestamp, event name, user name, and resource name. This allows you to track who did what and when and why. The CloudTrail Insight can also be enabled to detect and display autonomous activity logs. Please note that the CloudTrail Insight is a pet feature. The management events are related to the management operation on the resources. The data events, on the other hand, are related to the operation on specific resources. The management events are automatically recorded, but data events need to be explicitly enabled for logging. The CloudTrail insights are records for anomalous pattern detections, and this is the pet feature require CloudTrail insight to be activated. The CloudTrail insight identifies the unusual activity related to the API call and the error rate. The insight events related to API calls are generated for write management APIs, while events for API error rates are generated for the both write and read management APIs. The CloudTrail insight establishes a baseline based on the activity over the past 7 days. Any unusual increase in the number of API calls compared to this baseline is logged as an insight event. The trails are stored for 90 days, free of charge. And if you want to keep them for longer than 19 days, you will need to store them in S3, which incurs additional storage fees. The trails stored in S3 are encrypted using the SSE S3, and if you want to specify your own encryption key, you can use KMS. The AWS CloudTrail is a service that captures API calls for resources. The CloudTrail capture includes the location, API call, the IP addresses of the caller, the request and the response. On the other hand, if you want the database level activity, such as query and transactions, you need to use the auditing the functionality of each database engine. Sometimes the question about the trail that can be captured with the CloudTrail will be asked in the exam test. And this is the list of the auditing feature of each database engine. For example, regarding the MySQL, you can capture query activity using the MySQL Enterprises Audit plugin. Other database engines provide a similar auditing functionality. And this is a sample audit log for test user attempting to connect from the local host. Each entry shows the audit event and attributes such as the timestamp, user, and host. Next, I'm going to introduce AWS Config. The AWS Config is a service that logs configuration changes of AWS resources and evaluates whether they comply with the organizational rules. The config stands for the configurations. The config tracks the resource change history and evaluates the resource based on the specified timing. It is particularly useful for enhancing security and governance. For example, you can use the config to create rules that ensure the SSH connections are properly configured for EC2 instance. SSH is an encryption technology that secures traffic to EC2 instance. In this case, the config will track the EC2 instance startup and the modification history. If it detects that EC2 instance has been started without SSH configured, it will notify you that the rule has been violated and can trigger a corrective action if necessary. The AWS config allows you to set up the config rule to check compliance with your rules and receive notification when the resource doesn't follow the rules. The config rules include the AWS managed rules, which are provided by AWS by default, and the customer managed rules, which are customized by user. For example, one of the AWS managed rules is the restricted SSH, which checks whether SSH connection is configured for EC2 instance. The number of available rules has increased every year since the service was launched, and as of now, there are over 150 rules. When an event occurs, the config checks if the resource follows the rules and records the result. The rules can be evaluated continuously or on a daily basis. The continuous recording logs changes as they happen, while daily recording logs change only once a day. The continuous recording can be more expensive due to the higher number of notifications. The config is charged based on the number of rule evaluations. And you can integrate the config with the system manager to automatically fix resources that don't comply with config rules. The system manager's automation feature can trigger when the config rule is violated and automatically perform fixing actions. And you can use standard queries to search the log history, while CloudTrail is a service that tracks the API activity on user side. The config is primarily focused on capturing the change history on the resource side. And this is the sample JSON of the item that can be retrieved with the config and example query. I'd like to introduce some additional features of AWS Config. The config can manage on-premise resource as well as AWS resource. To manage on-premise resources, you need to register the target resource in the system manager. The config can also be used across the multiple accounts and regions. The fees are charged for config rules, conformance packs, and the configuration snapshot stored in S3. Conformance packs are a collection of the rules and the resources packaged together. Next, I'm going to introduce network security. First, I'd like to introduce an overview of the network services. On the left side, the image shows a network connected to the internet through the internet gateway. On the right side, it shows a network connected to the on-premise environment via the VPN using the virtual gateway. The area outlined in the red colors representing the AWS cloud space located in the region. In each region, the VPC, the virtual private cloud, is set up. A VPC is an address space that provides a sufficient number of IP addresses to host your resources. Inside the VPC, you can create a subnet, which is another address space. The subnet is where you actually place your resources. In the image on the left, there are both private and public subnet. The confidential data should be placed in the private subnet, which cannot be accessed directly from the internet. On the other hand, the public subnet hosts the web server and allows access from the internet via the internet gateway. On the right side, two subnets with the same configuration are placed in the different availability zones. And this setup ensures that if one subnet becomes unavailable, the other subnets can continue running the services. To allow access to and from the VPC, you need the gateway services. To access the internet, you use the NAT gateway, which converts the global IP addresses used in the internet space to local IP addresses used inside the VPC. An internet gateway also has NAT functionality. To connect the VPC with an on-premise site, you set up the virtual private gateway on the VPC side and the customer gateway on the on-premise data center side. And each subnet has a route table that records routing information, and it allows the routing between the resources, subnet, and the VPC. Additionally, each subnet is equipped with a firewall function called a security group. So now let me introduce the various services. Let me introduce an overview of the firewall service. And a firewall is a service that provides a network control to protect a system's security. AWS offers the services that correspond to both the application layer and the networking layer. The network layer firewall includes the network ACL, which controls traffic at the subnet level within the VPC, and the security group, which controls the traffic at the resource level. The firewall that operates at the application layer is AWS WAF. The WAF is designed to protect the web application by monitoring and controlling the HTTP and HTTPS traffic. The Route 53 Resolver DNS firewall operates mainly at the application layer and used to prevent the access to inappropriate site by controlling the DNS query responses. Network firewall operates at both the application at the network layer. It controls the traffic at the session and packet level, and provides the domain and the URL level control, and includes the intrusion detection and the prevention systems. The AWS Shield protects the resources from the DDoS attacks and mainly operates at the network and the transport layer. AWS Firewall Manager centrally manages all these firewall services. Another way to classify firewall is stateful or stateless firewall. The stateful firewall keeps track of the state previous connection and automatically allow packets that belong to previously allowed traffic. And this allows the firewall to maintain the context for traffic, where the context refers to the session state and the previous traffic patterns. The stateful firewall provides more advanced and traffic filtering based on this context. Stateless firewall, on the other hand, evaluates each packet individually without considering the previous state and sessions, and they apply predefined allow or deny rules to each packet, such as rules based on the IP addresses or protocol. Because they do not track the traffic context, the stateless firewall are generally faster. Security groups and WAFs are classified as the stateful firewall, while the network ACL are classified as the stateless firewall. The network firewall supports both stateless and stateful rules. You can control traffic using the security groups and the network ACL. The security groups are set at the instance level. In practice, they are attached to the resource's ENI, Elastic Network Interface. Network ACLs are set at the subnet level. Again, the security groups are stateful firewall, while network ACLs are stateless. The security groups control traffic at the instance level, specifically at the ENI. The network ACL controls the traffic at the subnet level. By default, security group allow internal traffic, and the network ACL allow the all traffic. The security groups and the network ACLs are often appeared on the exam test. It's important to remember the differences because it's often appeared on the exam. And this page summarizes the whether or not security group can be set. A security group is a virtual firewall that you configure for services running within a VPC. With IaaS and PaaS, such as database instances, you can configure a security group. On the other hand, you cannot set up the security group with the serverless service. I have summarized the points to consider when accessing the resources VPC B from the resources in VPC A. You need to consider IAM role in SC2 and the security group in the VPC A the S3 bucket policy, and the VPC endpoint. In this image, the VPC A has an EC2 instance, and the VPC B has an S3 bucket. And this is the example of the IAM role to attach to EC2 instance. And here, get object and put object are allowed inside the action field. If you want to retrieve and analyze the CSV file or packet file in S3, you need to add get object. On the other hand, if you want to add or change new data, you need to add put object. Specify the ARN in the resource field, and you need to follow the law of the least privilege. When setting up the security group, you need to specify protocol and address ranges, and it's similar to firewall. And if you forget to specify the inbound or outbound rules for database instance, the access error will occur. And just like IAM policy, you should configure S3 bucket policy for the law of least privilege. And here, we only allow access from the specific VPC endpoint, so we use the string not equal condition to deny unnecessary permissions. Next, I'll introduce VPC Flow Logs. The VPC Flow Logs capture the IP traffic logs from the ENIs, the Elastic Network Interfaces. And these logs can be sent to CloudWatch Logs, S3, or Kinesis Data Firehose for storage. VPC Flow Logs include the information like the source and the destination IP addresses, the port, protocol, packet count, the byte count, the timestamps, and the number of reject. And this allows you to check if the security groups are set up correctly and monitors traffic to your instances. However, the VPC Flow Logs only provide the metadata. They don't show the actual contents of the traffic. If you need to inspect the traffic content, you'll need a third-party firewall or the similar solution. Next, I'll introduce the VPC Peering. The VPC Peering connects the VPC through a private network. Since it uses the AWS private network, it enables secure communication without relying on the hardware and is designed to avoid a single point of failure. And you can create the peering connections between the different accounts and the regions. The VPC peering uses the private IP addresses within the VPC, so you don't need to assign the public IP addresses. Now, let's look at the cases where VPC peering cannot be used. If the CIDR blocks of the VPCs overlap, you cannot create the peering connections. Transitive peering is not supported. For example, even if you have the peering connection from the VPC A to VPC B and from VPC B to VPC C, the VPC A cannot communicate directly with VPC C. The VPC peering cannot be combined with other networking structure like the VPN connections, the Direct Connect, Internet Gateway, NAT devices in the private subnet, or the VPC endpoint for AWS services. Next, I'll introduce the VPC endpoint. To access another VPC from within your VPC, you normally need a public IP address. You either access resources with a public IP address in the public subnet, or use NAT gateway to convert a public IP into a private IP for accessing the resources in the private subnet. The AWS Service API endpoint are on the public network. If you want to access these resources privately, without exposing your IP address to the internet, the VPC endpoints are useful. A VPC endpoint is a virtual device that offers private access from within your VPC. And generally, an endpoint refers to the physical device used for the communications. There are two types of VPC endpoint, the interface endpoint and the gateway endpoint. For example, now you're gonna access an S3 packet in another VPC from your EC2 instance. With an interface endpoint, the requesting side endpoint communicates with the service provider's endpoint. The endpoint on the requesting side is called the interface endpoint, while the endpoint on the service provider's side is called the VPC endpoint service. And these endpoints are used AWS private link to securely connect without going through the internet. In contrast, gateway endpoint accesses the service provider's VPC through a gateway endpoint. In this case, no endpoint is created on the service provider's side. The gateway endpoints are used for Amazon S3 and DynamoDB, routing directly within the VPC without exposing the IP addresses. Here's a summary of differences between the gateway and interface endpoints. The gateway endpoints support S3 and DynamoDB, and they are free of charge. To connect, you need to add a route to gateway in your route table. Since it's routed within the VPC, the IP addresses are not exposed. It's not possible to access the gateway endpoint directly from the external endpoint. You need to set up the proxy server for external accesses. The interface endpoints support many services. Since you use the private link, they are pet services. ENI and DNS are associated with the interface endpoint. The DNS is specified in your application when making a request to the services. The interface endpoint allows private communication between the ENI and the service. And this also makes it simpler to connect from the on-premises environment without using the proxy server. Next, I'm going to introduce the VPN and Direct Connect. A VPN, the Virtual Private Network, is a technology that creates a virtual private communication network over the Internet. It enables secure communication without relying on the physical connections. So let me explain the key technologies that support VPN. A VPN creates a virtual tunnel between two locations. Even without a direct connection, it enables private network between them. Encapsulation makes context less visible from externally by wrapping in another protocol, and this makes the content secret. It supports encryption protocols like SSL and IPsec, which makes the data package unreadable. The authentication systems like SSO, the single sign-on, are used to ensure that only authorized user can set the data through the VPN. Since the VPN work over the Internet, they are affected by the Internet bandwidth. For example, in the areas with heavy usage, there is a risk of slower communications. Therefore, in the mission-critical system, you should consider deploying a dedicated line connections. There are two VPN connection methods, AWS Client VPN and Site-to-Site VPN. I will introduce each of them on the following pages. The AWS Client VPN, a VPN service that allows individual clients to connect securely to AWS. It can scale automatically based on the number of users, adjusting flexibility to change in demand. The AWS Client VPN provides an open VPN-based VPN. The client can access AWS resources by installing the software on their devices. It's used in the use case where, for example, the remote workers access the AWS cloud. The Client VPN support Active Directory, the Federation authentication, and the certificate-based authentication. And when deploying it, you can configure the VPN endpoint and use an ENI to exchange data between the client and AWS. And this allows you to manage access to both on-premises and the AWS resources. AWS Site-to-Site VPN is a VPN service that connects the on-premise data to VPN. And it supports IPsec to secure communications. It connects the customer gateway to the virtual private gateway. The AWS Global Accelerator allows you to configure an accelerated site-to-site VPN. This can improve the network performance by up to 60%. The VPN Cloud Hub allows you to establish a VPN across the multiple sites. You can connect the multiple customer gateway to a single virtual private gateway. And it's also possible to place several customer gateways within one on-premise network to configure redundant site-to-site VPN. As the number of site-to-site VPN connections increases, so will the cost. And here I will introduce the types of VPN, the Open VPN and IPsec VPN. The Open VPN works at the transport layer, and it's easy to set up, install software on your devices, making it popular for individual devices and smaller networks. And in contrast, the IPsec VPN operates at the network layer and is directly integrated with the Internet protocol. Since it's relatively complex to set up, so it's commonly used in the corporate network. The Open VPN is categorized as a software VPN, and IPsec VPN can be categorized as both software and hardware VPN. Since the hardware VPN needs a router or a VPN server, it makes less flexibility compared to software VPN. Next, I'll introduce AWS Direct Connect. Direct Connect is a dedicated connection service. It connects your customer router to Direct Connect router using the fiber optic cable. And this allows you to connect the AWS without using an internet service provider, providing the private and the dedicated connections. The Direct Connect offers two types of connection, the dedicated connection and the hosted connections. A dedicated connection uses the physical Ethernet associated with a single account. The supported port speeds are shown here. A hosted connection are operated by the AWS Direct Connect partner. The Direct Connect partners include, for example, the telecom companies like the AT&T, Verizon, and NTT. You can select the port speed depending on the partner. I will introduce the redundancy architecture using the VPN and Direct Connect. You can use a VPN as a backup for Direct Connect. And if the Direct Connect connection fails, the VPN will serve as a fallback. It's expensive to establish two Direct Connect connections, so to use the Direct Connection primarily, with a VPN as a backup in case of failure. And it recommends to set the speed as close as possible during the normal and failover conditions. For example, configure the VPN to handle 1.25 Gbps and the Direct Connect to handle the 1 Gbps. You can choose the level of resilience for your Direct Connect connections. You can choose from the maximum resilience, the high resilience, and the development and testing. The maximum resilience duplicates your Direct Connect across the multiple locations and also within the single location. The high resilience duplicates across the multiple locations but not within the single location. And the development and testing does not provide redundancy between the locations. To use Direct Connect, you need to create the virtual interfaces, the VIF. And these are three types of virtual interfaces, the private, the public, and the transit virtual interfaces. The private virtual interface allows for the connection via the private IP address. The public virtual interface is used for accessing the public AWS services such as S3 and EC2. And a transit virtual interface is associated with a transit gateway through a Direct Connect gateway. The public VIF connects the public endpoint, which poses the security risk. It also provides access via public endpoint, which means it can be subject to network congestion and the effort of users' traffic. The transit gateway serves as the central hub that simplifies the management and all the multiple connections, making of the transit VIF the straightforward solution for connectivity. The public IP address is supported only by public VIF. Additionally, you can connect to the multiple VPC with private VIF and the transit VIF. To connect the multiple VPC with the private VIF, you need the VPC Peering. Next, I will introduce Direct Connect Gateway. The Direct Connect gateways allow users to connect multiple VPC across the different AWS regions to their on-premise network through a single gateway. By using this gateway, the network architecture is simplified, making the data transfer between regions easier. With Direct Connect Gateway, you can establish a connection across the different regions. The VPCs connected through the Direct Connect Gateway cannot communicate directly with each other. The Direct Connect Gateway is designed to connect an on-premise network to multiple VPC, but it doesn't support routing between VPC. To enable direct communication between the VPC, you need to use a transit gateway. This allows the VPC to communicate directly with each other. Additionally, since the Direct Connect Gateway can connect up to the 20 VPC, if you need to connect more than that, the Transit Gateway is also the appropriate option. And you can also connect a single Direct Connect Gateway to multiple Transit Gateway across different regions. Next, I will explain LAG. The LAG, the Link Aggregation Group, is the logical interface that aggregates the multiple connections and treats them as single connections. With LAG, you can increase the available bandwidth, achieve redundancy, and enable load balancing across the connections. The available speeds are 100 Gbps, 10 Gbps, and 1 Gbps, but all aggregated connections must have the same speed. They also use the same Direct Connect endpoint. And finally, I will explain the pricing for Direct Connect. The Direct Connect charges are based on the port hours and the data transfer. The port hours are charged at a different rate depending on the bandwidth and the connection type. The billing starts either 19 days after the connection is created or when the connection between the Direct Connect endpoint and the customer router is established, whichever comes first. For data transfer with a private VIF, the charges apply to the AWS account transferring the data. For public WIF, the charges apply to the owner of the resources being accessed. And here I will introduce the broader gateway protocol, BGP. The BGP is a protocol used for exchanging and routing information between different networks on the Internet. It's primarily routing the protocol that makes up the entire Internet, allowing for the detailed control over the network routing. The BGP is known as the path vector protocol, where each BGP speaker maintains a list of AS paths that are reachable to them. The information is exchanged with the neighboring BGP speakers. For example, the BGP speaker 1 holds a list of AS paths to connect to the AS2. The autonomous systems AS refers to the network that forms the part of the Internet. This is managed by the Internet Service Provider or corporations. AWS Direct Connect can perform the routing between the client network and AWS using the BGP. Now I will introduce to the concept of the Content Delivery Network, CDN. A CDN places a cache between the client and the origin server to offload the origin and improve the response time to the client. The AWS offers the CloudFront as its CDN service. And without the cache, the requests from the client are sent directly to the origin server. Then the origin server responds directly to the client. In such cases, if a large number of the requests are sent by the client, it can lead to the high load on the origin server and a slower response to the client. By strategically placing the cache, the load on the origin can be reduced and the response times can be improved. The interaction between the client and the CDN are termed as the viewer request and the viewer response, while the interaction between the CloudFront and the origin are referred to the origin's request and the origin's response. Now I will introduce the AWS global infrastructure, the edge locations, and the point of presence, the POPs. As of now, there are over 600 POPs, the 400 edge locations, and the 13 region edge globally. The POPs are physical locations that transfer traffic between end user and the AWS data center. By hosting the CDN service at the edge location, you can reduce latency effectively. Since the CDN services are hosted at the edge location, these are also referred to as edge location services. And this is for your reference regarding the AWS resources and their locations. For example, RDS and EC2 are deployed within the VPC. The S3, while the global service, stores its data in specific region. The services that are located in the region are referred to as the regional services. On the other hand, the CloudFront and the Route 53, which offer the globally, are referred to as the global service. So let me introduce to the Amazon CloudFront. The Amazon CloudFront is an advanced CDN service. It delivers the cached content from the global edge locations. The CloudFront offers the fast distributed delivery, the DDoS protection using the WAF and the AWS Shield, and the reporting features. Additionally, the pricing is based on the amount of the data transferred and the number of the requests, making it as the pay-as-you-go service. In CloudFront, it's important to control caching effectively. With compressing the content, you can optimize the communication speed and reduce cost. And it's also important to set the cache retention period. If the time to read (TTL) of the cache is too long, the outdated content remains on the cloud front even after the update at the origin, preventing the latest content from being delivered to the client. On the other hand, if the TTL is too short, it returns in a lot of requests to the origin server. A cache hit occurs when CloudFront returns cached content in response to the client request. In CloudFront, it's important to set the appropriate cache retention period based on the request types and the cache hit rate. The CloudFront charges for the data transfer, the calls to CloudFront functions, and the requests to the Lambda functions. If you configure an AWS resources at the origin, there are no data transfer charges between the CloudFront and the origin. However, if you use an external resources as origin, the data transfer charges between the CloudFront and the origin will apply. I will introduce the security features of CloudFront. The CloudFront has SSL certificate enabled by default, which encrypts the communication between the client and the CloudFront and between the CloudFront and the origin server. The CloudFront also supports WAF and AWS Shield. The AWS Shield protects your resources from DDoS attacks. For access control, the CloudFront supports restrictions based on the geographic location and IP addresses. And if the origin is S3 bucket, you can set the S3 bucket policy to allow the request only from the OAI. If the origin is an ALV, you can configure it to route requests only when a specific HTTP header is included. Now I will explain the detailed settings on the next page. The CloudFront also supports the signed URL and signed cookies. So I will explain how to control access when S3 buckets are the origin. And here is a sample S3 bucket policy that allows a request from an origin access identity OAI. And you set the principal to the OAI. Here, the OAI, your identity ID, will be the ID of the OAI. And this setup means only users with the CloudFront OAI can access the content in the S3 bucket. And it prevents the direct access to the data in the S3 bucket from outside sources. By routing all traffic through the CloudFront, it improves the security. So next, let's look at the example where the origin is application load balancer. The routing is possible only when the request includes a specified HTTP header. In this example, the requests are routed to the target group 1 only if they contain a custom header named X custom header with the value header value. Conversely, the requests that do not include this custom header cannot be routed to the target group. Next, I will introduce signed URL. The signed URL are used to grant access to specific users only. And here is an example of the signed URL. A signed URL consists of the CloudFront distribution, the file path, the expiration parameter, the signature parameter, and the key pair. As I mentioned in the S3 chapter, signed URL includes the expiration. And once the expiration is reached, the URL becomes invalid. Next, I will introduce the signed cookies. The signed cookies are evaluated as the CloudFront edge locations. Using the signed cookies, you can access private content only if the cookie is valid. and it's associated with the specific URL. The signed cookies include a key pair, a signature, and a policy. The policy can specify the URL, the end expiration, and even a range of IP addresses. Next, I will introduce edge functions. The edge functions run at edge locations. With edge functions, you can customize how CloudFront distributes and handle HTTP requests and responses. The edge function performs actions on requests and responses passing through the CloudFront. For example, you can write code for basic authentication and authorization, or to generate HTTP responses. The purpose of the CloudFront is to reduce the load on the origin server. So, by executing the process at the CloudFront instead of origin, you can further reduce the load on the origin server. There are two types of edge functions, the CloudFront functions and the Lambda at edge. The CloudFront functions support JavaScript, while the Lambda at edge supports the Node.js and Python. Generally, the CloudFront functions are used for the simpler task, while a Lambda is used for more complex process. The CloudFront function typically handles the request coming from the viewers, and the Lambda at edge can handle the wider range of use cases, serving both viewers and the origin. And compared to regular Lambda functions, the Lambda at edge functions have shorter execution times and require less storages. And this means that Lambda at edge has less processing power than regular Lambda functions. And this is a sample of Lambda at edge. And this is sample trigger user authentication for the viewer request event. The request is executed only if the authentication header is correct. And first, I will explain the general functions of DNS, the domain name system. The DNS is responsible for matching domain name with IP addresses. Since IP addresses are numerical information, it's difficult for you to recognize. Then, domain names are used to access the specific resources or website. DNS responds to the client queries with the corresponding IP addresses. A DNS client sends a request to a DNS server to convert a domain name into IP addresses. A caching DNS server speeds up the response time by sorting these queries. If the caching DNS server already has the answer to the query, it returns to the IP address directory. If not, it will query a higher level DNS server. And the authoritative DNS server holds the final record for domain. And forwarder is a DNS server that transfers query to the other DNS server. The DNS queries are recursible, which means that the DNS client asks the DNS resolver for a complete answer. The resolver will repeatedly query the other DNS services until it finds the requested DNS record in response to the client request. And these are the records used by Route 53. In particular, alias records are the AWS specific record type that can be mapped to AWS resources. When the IP address of AWS resource changes, the DNS is automatically updated. Amazon Route 53 is a DNS service. It offers a domain resolution, DNS routing, and health checking capability. And not only them, but it also offers a lot of functions such as the policy-based routing beyond ordinary DNS services. A Route 53 is an edge location service that provides a high availability and performance. I will explain how DNS queries are resolved in Route 53. First, the end user types the domain name www.example.com into their browser. The user's computer queries a DNS resolver to convert the domain name into an IP address. The DNS resolver starts by querying the DNS root name server, requesting the information about the .com top-level domain. The domain names consist of the several parts, with .com being the highest level in this example. The name resolution occurs in the order from the highest level domain, such as .com, .co.jp, or .organizations. The root name server directs to the top-level domain name server, which in case manages the .com domain. The top-level domain name server further forwards the query to the Route 53 name server, specifically to the servers managing the example.com domain. The Route 53 name server returns the IP address, the 192.0.2.44 for requested domain name www.example.com to the DNS resolver. The DNS resolver then sends this IP address back to the end user's computer. Then the user browser uses this IP address to connect to the web server. The Route 53 offers several routing policies. The simple routing policy, it maps IP address directly to the domain names on one-to-one basis. The failover routing policy, in an active-passive setup, this policy routes traffic to a solely server's IP address in the event of failure. A geolocation routing policy routes traffic based on the user's location. And the geo-proximity routing policy directs the traffic to the nearest server when multiple servers are distributed across the various locations. The latency routing policy routes traffic to the location with the lowest latency. The IP-based routing policy routes traffic based on the IP addresses and user's location. The multi-value answer routing policy accesses servers almost randomly when multiple servers are distributed, and this is typically used for load balancing. As for weighted routing policy, it determines routing frequency based on the specified weight or time proportions. And these policies are often appeared on the exam test, so please keep them in mind. And geolocation routing and geo-proximity routing are similar but have the slight difference in use case and settings. On the left, geolocation routing routes traffic based on the user's location. For example, the users in Tokyo are directed to resources in the Tokyo region, while users in America are directed to the resource in the North Virginia regions. There are also use cases like restricting the access to Tokyo-specific resources only to the users from Japan, and routing access from the abroad to solely server. The geo-proximity routing considers the location of both the client and the resources when routing. It routes traffic based on the proximity, meaning it directs the client to the nearest available resources. And you can improve the security with the routing policy. The multi-value answer routing policy allows the Route 53 respond to DNS query using up to 8 randomly selected healthy records. The policy doesn't return IP address that fail health checks, which ensures that routing is only to resources that are functioning correctly, thus improving the security and availability. The geolocation routing policy routes traffic based on the user's location. It can block access from the outside the service region, thereby preventing the unauthorized access and the potential attacks from the outside the service area. And finally, I will introduce the Route 53 resolver. Route 53 resolver resolves DNS query within a VPC. It also functions as a forwarder, transferring the DNS query to name servers. For publicly available domains on the Internet, it performs a recursive query to the public name servers. You can configure hybrid DNS access with on-premise site by setting up inbound endpoint and outbound endpoint and outbound rules. The inbound endpoint allows DNS query from outside network to the Route 53 private hosted zone. The outbound endpoint enables DNS query from the VPC to other network. And this image shows the placement of DNS server in the hybrid environment. It resolves the query from AWS to on-premise name server across two availability zones for redundancy. Then I will introduce CI/CD. A development process consists of the stages: the build, test, deploy, and the release. The continuous integration, CI, refers to the automating the development, the building, and the testing of the source code to validate the program. And this method is used to avoid human errors and improve efficiency. The continuous deployment and the continuous delivery refer to the methods that automate the process of releasing the developed program to the production environment. By automating the repetitive deployment task, and these methods help avoid errors and improve efficiency. And these are deployment tools of AWS, which includes the code build and the code deploy. The code pipeline orchestrates the entire process from commit to deployment, and some tools were discontinued in 2024. And on the next page, we will introduce the AWS Code Services. The AWS previously provided the code commit, but the service has been announced discontinued. You now use Git repository. The code build and the code pipeline can directly fetch code from GitHub, GitLab, and Bitbucket. When the multiple engineers collaborate on the development, the Git is used to avoid the conflict. The developer create, modify, or delete code in their local environment, and the Git add commands to reflect it from the working directory to the index. And then Git commits to commit changes from the index to the local repository. And after that, using the git push command, the changes are sent to the remote repository, a shared workspace. The code build is a free managed service that provides the build and the test environment. Because it's free managed, it can automatically scale to handle fluctuation in request volume. The code build offers compilation and the build environment, and you can easily set up the environment from the console. It supports various programming languages and Docker. Additionally, as a source, it supports code commit, S3 buckets, GitHub, and Bitbucket. You can also specify the Jenkins, an open source automation tool, as a plug-in. The Jenkins is an open source CI/CD tool used for automation and offers many extensions to facilitate development. And you can define the pre-build and post-build environment using the build spec file. The build spec includes the software installation, the dependency installation, and the commands to run during and after the build. And here is the pricing for code build. In code build, you can specify the instance type, and the cost varies depending on the instance type. The pricing is based on the memory, the CPU, and the build duration. The code deploy is a service that deploys applications to the production environment. The supported deployment target include EC2 instance, container, Lambda, and even on on-premise servers and outside of AWS. You can specify the S3 bucket or GitHub to deploy the application revision. Just as you can define the build spec in code build, in code deploy you can define the deployment environment variable using the appspec YAML file. And this includes the deployment infrastructure, load balancer, the platform settings, the network configuration, and the capacity provisioning. The code deploy offers deployment options, and which are similar to those in Elastic Beanstalk and the CloudFormation. And for EC2, you can choose from the all at once, half at a time, or one at a time. The all at once makes the deployment time short, but it returns in system downtime. On the other hand, other options minimize the downtime. For deployment to ECS, there are two options, the canary and the linear. In the canary deployment, a small percentage of the release is deployed first and followed by the remaining portion. For example, after releasing the first 10%, the remaining 90% is deployed. And the linear deployment, a small percentage is released initially, and then deployment progresses linearly at a specified interval. For example, after releasing the first 10%, the remaining 90% is deployed 10% at a time every minute. The AWS code pipeline enables you to consistently manage the entire deployment process. It supports not only AWS services, but also various repositories, the build and deployment services. Once code is modified, the code pipeline automatically builds, tests, and deploys. If the process succeeds, the deployment proceeds. If it fails, it identifies the error location. Next, I'm going to introduce the cost management service. The AWS Budget is a budget management service. With AWS Budget, you can set up alerts that notify you when your spending exceeds your budget threshold. And you can monitor your spending against your budget on the dashboard. The budget can be set for cost, usage, reservation, and saving plans. For example, you can create the budget based on the EC2 instance running hours capacity. Next, I will introduce the Cost Explorer. The Cost Explorer visualizes the cost and the usage of your resources. While AWS Budget focusing on the budget, the Cost Explorer focusing on the cost usage. You can filter by categories such as the resources, region, accounts, and the tags. You can also forecast the future cost by including the future date. The Cost Explorer also allows you to monitor the usage of reservations. The Cost Explorer will likely to be the most commonly used tool for managing cost. If you're working on the hands-on, you can use the Cost Explorer to track your spending. A cost and usage report is a reporting service that compiles the detailed and extensive data. The report can be exported in CSV format and provides a comprehensive summary of detailed items such as resources, accounts, and regions. And you can store the reports in S3 bucket, where they are organized by date. You can use Amazon Athena to analyze the reports. Next, I will introduce the saving plans. The saving plans offer a discount for commitment for 1 or 3 years. There are 3 types of plan available: the compute saving plans, the EC2 instance saving plans, and the Amazon SageMaker saving plans. You can get a discount by upfront payment. The larger the upfront payment, the greater the discount rate. The EC2 instance saving plans offer discount specifically for EC2 instances. The compute saving plans provide discounts not only for EC2, but also for other compute services like the Fargate and Lambda. The discount rate is higher with EC2 instance saving plans. However, these plans are limited to specific instance family and region. If there is a possibility that your instance family or size might change in the future, it's better to choose compute saving plans. You can purchase saving plans from the Cost Explorer console. When buying the saving plans, you specify the plan type, the commitment period, and the payment option and the start date. For EC2, you also have the option to purchase the reserved instances. The differences between saving plans and the reserved instance are summarized in this table. The saving plans are more flexible because you only need to specify the commitment period, the payment option, and hourly usage to receive the discount. On the other hand, reserved instances require you to specify the instance size, availability zone, platform, and tenancy. And if you've already purchased a reserved instance, it will be applied first, followed by the saving plans. This ensures that your existing reserved instances are fully utilized. And finally, I will introduce to the tags. The tags are metadata used to identify and organize resources. The metadata generally refer to the data about the data, such as attribute, the creation date, and so on. The metadata classify the resources but doesn't affect their functionality. The tags consist of the keys and values. In the cost management services we've discussed so far, you can filter by tags. And this is an example of common tagging patterns. Tags allow you to categorize resources by the department, the project, the environment, and so on. For example, by tagging resources according to the company department, you can create a cost report for each department. Next, I'm going to introduce practice questions. I have also released the practice test on Udemy. The practice test includes the 5 original tests. I can issue coupons, so if you need one, feel free to send me a message. And this is the sample questions. Then you will choose the appropriate solution from these questions. In this case, the answer is C. The breakdown the requirement in the question text. In the exam test, there are multiple requirements listed within the single questions. In this example, there are 4 requirements. You must choose the best solution that meets these requirements. The correct choice is option C, which includes the Redshift, Data Firehose, and the QuickSight. So keep in mind the features and the use cases of the services. I'm going to point out the preparing for database exam. From my experience, the quantitative and the calculation questions are not frequently asked in the exam. What often asked are the use cases. The exam duration is 130 minutes with 65 questions, and this means you have about 2 or 3 minutes per questions. I think this should be sufficient to work with the questions. And unlike the solution architect exam, the data engineer exam doesn't have the wide variety of questions. the similar services and features are repeatedly tested. And therefore, I believe the mastering the content of this course and the practice questions will be sufficient for you to pass the exam. In this course, I utilize the practice test features on Udemy. You can take the test at any time, pause it midway if you need it, and retake it as many times you want. Once the test is completed, you can review the result and explanations. So let's go ahead to the practice test. In Chapter 4, in the summary of this course, I will introduce the pricing calculator, support plan, marketplace, and learning resources. The AWS pricing calculator is a tool to help you estimate your cost. You can input your resource usage, such as the number of EC2 instances, and the calculator will provide a detailed breakdown. You can estimate the cost, save and share the estimate, and get recommendations. And for your reference, the image shows the pricing trends for EC2 and S3. The prices of the cloud have been going down over the years. Because of the competition between cloud providers and improvement in technology, these prices are expected to keep dropping. The prices and the services from all cloud providers changes often, so it's important to stay updated. The AWS Partner Network, or APN, is a global program whose purpose is to identify AWS partners who can assist the clients. The APN consists of the two types of the partners. The consulting partner helps clients design, architect, build, migrate, and manage their workload in AWS. The technology partner is independent software vendors that develop and offer software solutions optimized for AWS. They provide services such as SDK, APIs, and other tools to assist in the integration of client applications with AWS services. The partners in the APN can get benefits including the training, the certification program, the marketing and sales support, technical support, and access to AWS resources. And this is a list of AWS support plans. By choosing a pet plan, you can receive more comprehensive support. The further to the right you go, the more extensive the support becomes, including the technical support from the terms and the faster response times. The AWS repost is a QA community where members can post questions, and a member of the community provides the answers. And with AWS Marketplace, you can purchase software and services from the third-party vendors. You can utilize the marketplaces to discover solutions tailored to your specific need. For example, in EC2, you can purchase machine images with software from the third-party vendors. And here are the official learning resources. While I've covered what on the exam, but I recommend for you to check the official document. The AWS also has a training site called the Skill Builder with sample questions. The AWS announces new services at events like re:Invent and the AWS Summit. If you use AWS often for work, it's good to attend these events. And thank you for staying with me throughout this course. I also offer courses on AWS, the Google Cloud, and Microsoft Azure. Please stay tuned as I will expand my offering in the future. With that, we've come to the end of this course. I hope the content has been valuable to your learning journey. And thank you for dedicating your time with me, and I wish you success.